Hello there, and welcome to Just About Earth, that quiet little corner where curiosity slows down, science stretches out comfortably, and the world feels just a bit softer around the edges. Wherever you happen to be listening from tonight, whether it's a dimly lit bedroom, a long highway, a late-night kitchen with the hum of a refrigerator in the background, or a pair of headphones tucked gently against a pillow, I'm glad you found your way here. This is a space for wondering without rushing, for learning without strain, and for letting the mind wander while the body settles in. Before we drift into tonight's journey, let me ask you something simple and personal. What time is it where you are right now? Is the sky outside your window still holding on to the last traces of daylight, or has the night fully wrapped itself around your world? Maybe it's early morning and the air feels fresh and untouched. Or perhaps it's deep into the evening and the quiet has that special heavy softness that only comes when most of the world has gone to sleep. Wherever you are on the clock, this moment belongs to you, and if you find this gentle exploration calming, interesting, or just a pleasant way to unwind, you can always let that little like button know or consider subscribing to this cozy corner of the internet. It helps these slow, thoughtful stories find their way to other curious minds who might need a peaceful pause in their day or night. There's no rush though. For now you can simply listen, breathe and settle in. Tonight we're going to talk about something so vast, so powerful, and yet so quiet in its modern form that most people walk past it without ever realizing what it once was. We're going to talk about a sea. Not just any sea, but one that disappeared, and then, in one of the most dramatic natural events Earth has ever experienced, came back in a way that still echoes through stone, sand and water millions of years later. Imagine, just for a moment, standing at the edge of a world where an entire ocean is missing, not frozen, not drained by machines, not hidden beneath ice, simply gone. Where today there are waves rolling in gentle repeating patterns, where sunlight glitters on blue water and ships trace thin white lines across the surface, there was once a vast dry basin, a place of heat, salt, wind, and silence. A place that sat far below the level of the world's oceans like a giant empty bowl carved into the face of the planet. This is where our story begins. Not with a flood, not with rushing water, but with absence. The Mediterranean Sea, the familiar stretch of water cradled by Europe, Africa and the Middle East, did not always exist in the form we know today. There was a time long before humans, before cities, before even the animals and plants we'd recognise as modern, when this entire region went through a dramatic transformation. The connection between this basin and the vast Atlantic Ocean was cut off, and when that happened, something strange and slow began to unfold. Water kept evaporating under the sun, rivers still flowed in from the surrounding land, but without a steady supply from the open ocean, the balance tipped. Over thousands of years the sea level dropped, and dropped, and dropped some more. What was once a thriving marine environment became in many places a deep, salty depression. Salt flats formed, thick layers of minerals settled on the exposed floor. Winds swept across wide, empty expanses where fish once swam and currents once flowed. The Mediterranean, for a time, became something closer to a giant, shimmering desert basin than a sea. If you'd somehow been able to stand there, millions of years ago you might have looked out across a landscape that felt almost alien. The air would have been hot and dry in many places, heavy with the sharp scent of salt. The horizon would have stretched far and wide, with distant cliffs marking the edges of continents that today meet the water's edge. Rivers would have carved deep canyons as they plunged down toward the low-lying centre of the basin, chasing a vanishing shoreline that kept slipping farther away. All of this happened quietly, without thunder or drama. Just the steady work of gravity, sunlight and time. And then, after this long period of stillness and waiting, the planet prepared for something entirely different. Somewhere at the western edge of this emptying world, between what we now call southern Spain and northern Africa, the land that separated the Atlantic Ocean from the Mediterranean basin began to change. Tectonic forces, those slow, powerful movements deep within the Earth's crust, shifted the shape of the land. Cracks formed, low points developed. The barrier that had held back an entire ocean started to weaken. You can picture it like a massive natural dam, not built by hands, but by continents themselves. For a long time, it held. And then, at some moment in deep time, it did not. Scientists believe that when the Atlantic finally broke through, the result was not a gentle trickle. It was not a slow stream. It was something closer to a planetary scale waterfall. But we're getting ahead of ourselves. For now, let's stay in this quiet, almost peaceful version of the world. A Mediterranean basin without a sea. A place shaped by sun and salt, carved by rivers falling into depths far below what we'd call sea level today. A world waiting, even if it didn't know it yet, for water to return. It's interesting to think about how the planet can hold on to moments like this. We tend to imagine Earth as stable, solid and unchanging beneath our feet. Mountains feel permanent, seas feel eternal. But when you stretch your sense of time out far enough, even oceans can vanish and return, and entire landscapes can be rewritten in what is, geologically speaking, the blink of an eye. As you listen, you might notice how the idea of waiting plays a role here. The land waited. The basin waited. The Atlantic itself pressed quietly against its boundary, wave after wave, day after day, year after year, for what would eventually become a very dramatic release. And in that waiting, layers of history built up. Salt deposits grew thicker, sediment settled. The surrounding land adjusted to a world where rivers flowed down into a deep, dry centre, instead of meeting the sea at a familiar shoreline. Plants and animals adapted to new conditions along the edges of this vast depression. All of this set the stage for what would come next. It's sometimes comforting to think of the planet as patient. It doesn't rush. It doesn't hurry. It doesn't care about deadlines or calendars or the ticking of clocks. It moves on scales of time that make our entire recorded history feel like a single breath. And yet, when it does act quickly, when something finally gives way, the results can be almost unimaginable in their scale. Before the water returned, though, there was a specific place where everything hinged. A narrow stretch of land that, in the grand scheme of things, wasn't very wide at all. A kind of gateway between two worlds. On one side, the full vast Atlantic Ocean, deep, heavy, and endless in every direction. On the other, the empty, sun-baked Mediterranean basin waiting far below. That narrow gate is what we now know as the region around the Strait of Gibraltar. Today, it's a busy passageway for ships, a meeting point of cultures, and a place where two great bodies of water touch. But millions of years ago, it was something far more dramatic. It was the line between a full ocean and a missing one. The edge of a natural dam holding back a volume of water so large that, if released, it would change the face of an entire region. You can imagine standing there, in your mind on that ancient landscape. Looking west, you'd see the Atlantic stretching out, waves rolling in from distant storms and faraway horizons. Looking east, you'd see land dropping away, descending into a basin that sank deeper and deeper toward its centre. The difference in height between these two sides wasn't small. Scientists estimate that parts of the Mediterranean basin were more than 1 kilometre lower than the Atlantic Ocean. That's like standing at the edge of a cliff taller than most mountains, except instead of air below you, there was a vast, empty space where a sea used to be. Gravity, patient and relentless, was always there, ready to pull water downward. All it needed was a path. Somewhere in that narrow region, a low point formed. Maybe an earthquake shifted the land. Maybe erosion slowly wore it down. Maybe a combination of forces worked together in a way we can only reconstruct through layers of rock and careful measurement. However it happened, the barrier eventually failed. At first, it might have been a small flow, a stream of Atlantic water slipping through a crack, beginning its long fall toward the empty basin below. But water is powerful in a way that sneaks up on you. Once it starts moving downhill, it doesn't just go, it pulls more with it. The flow erodes the path, making it wider, deeper, faster. What might have begun as a river quickly became something else entirely. And while we'll take our time exploring that moment in detail later, for now, it's enough to sit with the idea that this quiet, sun-drenched, salt-covered basin was on the verge of being transformed by one of the largest floods the planet has ever known. As you listen, you might notice how your own sense of time shifts when thinking about these enormous scales. Minutes can feel small, hours can feel soft and flexible. Millions of years, though, stretch the imagination in a different way. They become more like landscapes than numbers, wide and open, something you move through slowly rather than count. And here we are, moving slowly together through a story that's as much about waiting as it is about rushing, as much about stillness as it is about motion. Before the first truly massive surge of water poured into the Mediterranean basin, the world around it was already in motion. Continents were drifting, even if only by centimetres each year. Climate patterns were shifting. The global ocean itself was rising and falling in response to ice, temperature, and the slow breathing of the planet. Everything that was about to happen was part of a much larger system, one that doesn't isolate events into neat boxes. The flood wasn't just a flood. It was the result of tectonics, climate, gravity, and time all working together, patiently setting the stage. There's something oddly calming about that idea. Even the most dramatic moments in Earth's history don't come out of nowhere. They're built, piece by piece, layer by layer, by countless small changes that add up to something enormous. But for now, you can stay here, at the edge of this quiet world, just before everything changes. A place of sun and salt and deep, empty space. A narrow gate standing between an ocean and a basin that hasn't felt waves in a very long time. Take a slow breath. Let the image settle. Somewhere far back in time, long before coastlines were traced on maps or ships learned to follow the curve of the horizon, the world around the Mediterranean looked and felt profoundly different. Not in a dramatic, thunder-filled way, but in a quiet, almost unsettling way, as if the planet itself had taken a deep breath and decided to hold it. The sea that today glimmers between three continents was, for a while, absent. In its place lay a vast open basin stretched wide beneath the sun, shaped by gravity, wind, and the slow patience of geological time. If you imagine standing there in that ancient world, you wouldn't hear the familiar sound of waves. There would be no gentle lapping against stone, no rhythmic crash along a shoreline, no salty mist carried on a coastal breeze. Instead, the air would feel dry in many places, warm and heavy with the sharp, mineral scent of exposed salt and sun-baked sediment. The sky would still be wide and blue above you, clouds would still wander across it, and the sun would still rise and set in its steady, predictable arc. But below all of that, where water once rested, there would be land. This basin was not flat like a desert plain. It was shaped like a giant, uneven bowl, dipping downward toward its centre, sometimes gradually, sometimes in steep, dramatic drops. Along the edges, where the continents of Europe, Africa, and the Middle East framed this empty space, cliffs and slopes mark the former shoreline. Rivers, which had once flowed into a full sea, now had farther to travel. They cut deep channels as they plunged down toward the basin's lowest points, carving canyons that in some cases reached depths that modern rivers rarely approach. You can think of these rivers as explorers in their own right, tracing new paths across a changing world. Water, after all, always looks for the lowest point, and when the Mediterranean basin dropped far below the level of the surrounding land, it became a powerful draw. Streams and rivers from distant mountains and hills followed gravity's quiet instructions, descending into this vast depression, sometimes forming waterfalls where the land dropped sharply, sometimes spreading into braided channels across wide, dry flats. In the centre of the basin, conditions were often harsh. Without the moderating influence of a large body of water, temperatures could swing more dramatically. Days could be hot, with sunlight reflecting off pale, salty surfaces. Nights could cool quickly, as the dry air released heat back into the sky. Over time, thick layers of salt and other minerals built up on the exposed floor, left behind by water that had evaporated under the sun's steady gaze. This wasn't a single, uniform environment. The basin held a patchwork of conditions. Some areas may have supported shallow temporary lakes fed by rivers or seasonal rains. Others would have been stark, open expanses where the ground cracked and glittered with crystals of salt. Wind played its part too, lifting fine grains of sediment and carrying them across the landscape, reshaping small features, smoothing edges, and leaving subtle patterns in the dust and sand. It's easy to picture this place as completely lifeless, but life has a way of finding footholds in surprising environments. Along the edges of rivers, and in regions where fresh water collected, plants could take root. Insects and small animals followed. Birds may have crossed overhead, moving between distant lands, using these scattered patches of water and vegetation as brief resting points. The basin, though dramatically changed, was not entirely silent. It simply told a quieter, more subdued version of the story of life. What makes this period especially fascinating is how different it is from the image most of us carry of the Mediterranean. Today it's associated with blue water, bustling ports, warm breezes, and coastlines shaped by waves. But in this earlier chapter of its history, it was something closer to an inland world, a deep, sunlit hollow in the middle of continents, shaped more by air and gravity than by tides and currents. The reason for this transformation lies in a simple but powerful idea. Water needs balance. For a sea to remain stable, the amount of water flowing in has to roughly match the amount flowing out or evaporating. In the case of the Mediterranean, the main source of incoming water is the Atlantic Ocean, through the narrow connection at what we now call the Strait of Gibraltar. When that connection closed or narrowed enough to restrict flow, evaporation began to win. The sun, doing what it always does, continued to pull water into the air. Over time, more water left the basin as vapour than arrived through rivers and limited ocean connections. The result was a steady lowering of the sea level, a slow retreat that exposed more and more of the basin floor. This process didn't happen overnight. It unfolded over thousands of years, possibly longer. To the land and the sky, it would have felt gradual, a shoreline that crept outward, a river that had to travel a little farther each year to reach the water, cliffs that grew taller as the sea pulled away from their base. And yet, when we look back at this period now, knowing what came before and after, it feels like a dramatic pause in the planet's story. A moment when an entire sea stepped aside, leaving behind a vast stage of rock, salt, and sun. As you picture this, it might help to imagine the scale. The Mediterranean basin covers millions of square kilometres. Even partially drained, it would have stretched beyond the horizon in many directions. Standing anywhere near its centre, you would see land and sky meeting in a wide, distant curve, with no hint of water unless you were close to one of the rivers or temporary lakes. The silence, in terms of ocean sound, would have been striking. No distant roar of surf, no rolling echoes of waves, just wind moving across open ground, the occasional call of a bird and the soft, persistent sound of water, flowing in narrow channels where rivers made their way downward. Geologists today can still find the fingerprints of this time. Thick layers of salt, sometimes hundreds of meters deep, lie buried beneath the modern seafloor. These deposits, known as evaporates, formed when seawater repeatedly evaporated, leaving its dissolved minerals behind. They're like a record written in crystals, telling a story of a sea that once vanished and returned. The land around the basin also carries clues. Ancient river valleys, now submerged beneath the Mediterranean's waters, reveal how deeply those rivers cut when they had to descend into a much lower basin. Some of these channels are far deeper than modern river valleys, a sign of the dramatic difference in elevation between the surrounding land and the basin floor at the time. While this might sound like a remote, almost abstract piece of Earth's history, it has a strangely familiar quality. Many of us have stood at the edge of a dried-up lake or reservoir and felt a similar sense of absence. A wide, open space where water once was. Cracked mud, exposed stones, and the faint outline of an old shoreline marking where waves once reached. Multiply that feeling by millions of square kilometres, and you begin to get a sense of what this ancient Mediterranean world might have felt like. The sun, of course, kept shining through all of this. It rose and set, casting long shadows across the basin floor in the morning and evening, and bleaching the salt flats white at midday. Clouds drifted overhead, sometimes dropping rain that would briefly darken the ground and send thin streams of water racing across the surface before disappearing again. Seasonal changes still played their role. In wetter periods, rivers would swell, feeding larger lakes or wetlands in parts of the basin. In drier times, those waters would shrink back, leaving behind new layers of minerals. The landscape was dynamic, even without the presence of a true sea. There's something quietly humbling about imagining this version of the world. It reminds us that what we consider permanent is often just temporary on a long enough timeline. Seas can come and go, mountains can rise and wear down, entire climates can shift. The planet isn't a static backdrop for life, it's an active participant in the story. As the basin waited under the sun, forces far beyond its edges were already shaping what would happen next. The movement of tectonic plates, slow but relentless, continued to press and pull at the land that separated the basin from the Atlantic. The global climate influenced sea levels and rainfall patterns. Even small changes accumulated over long periods had the potential to tip the balance. It's a bit like watching a glass slowly fill on a table. Each drop doesn't seem like much on its own, but eventually the water reaches the rim, and then, with one more small addition, everything changes. In the case of the Mediterranean basin, the glass wasn't filling with water yet. It was waiting for a connection to open, for a path to form, for gravity to be given an opportunity to do what it does best. The land around the future Strait of Gibraltar was a critical piece of this puzzle. This narrow region between what is now southern Spain and northern Africa acted as a barrier, a natural wall holding back the Atlantic. But barriers, even massive geological ones, are rarely perfect. They crack, erode, and shift. Rivers on the Atlantic side would have flowed toward this barrier, sometimes pooling, sometimes cutting into the land. Rain and weather war at the surface. Earthquakes, though infrequent on human timescales, could reshape the terrain in moments. Over long periods, all of these processes worked together, slowly weakening the divide. From the perspective of the empty basin, though, nothing seemed to change. The sun still rose, the rivers still flowed, the salt still glinted in the light. It was a world defined by patience. If you let your mind wander there for a moment, you might notice how different your own sense of time feels when you think about these scales. We measure our lives in years, sometimes in decades. We mark time with calendars, birthdays, and anniversaries. But this landscape was shaped by hundreds of thousands, even millions of years of slow motion. In that context, waiting isn't an inconvenience. It's the default state. The basin waited for water. The land waited for movement. The planet waited for the right combination of conditions to come together. And when they did, the change would be sudden by geological standards. The kind of sudden that leaves deep marks in rock layers and reshapes entire regions. But before that, there was this long, quiet interlude. A chapter defined by sun, salt, wind, and gravity. A time when the Mediterranean was not a sea, but a vast open space cradled by continents. The idea that an entire ocean-sized body of water could simply step away, leaving behind a hollowed-out world, can feel almost unreal. Yet the evidence is there, written into the earth itself, in the layers beneath the modern seafloor, in the shapes of submerged valleys, in the chemistry of rocks that formed under dry, evaporative conditions. Science, in this sense, becomes a kind of listening. We can't hear the wind that once swept across those salt flats. We can't see the sun glinting off mineral crystals millions of years ago. But we can read the traces they left behind and piece together a picture of a world that no longer exists. As this picture comes together, it sets up a powerful contrast with what's to come, from stillness to motion, from emptiness to abundance, from a basin defined by absence to one defined by an overwhelming return. It's enough to sit with this image of a silent, sunlit world, a place where rivers carve deep paths into exposed land, where salt built up in thick, gleaming layers, where the horizon stretched wide and water was something that belonged mostly to memory. You can imagine standing at the edge of one of those ancient cliffs, looking down into the basin, the air warm on your skin, the wind moving slowly past. Far below, a thin ribbon of a river winding its way across the open floor, disappearing into a distant shimmer of light and heat. There's no hint in that moment of what's coming. No sound of distant surf. No rising tide. Just land, sky, and time moving at its own unhurried pace. And somewhere beyond the western horizon, an ocean waits. At the western edge of that vast, sunlit basin, where land sloped upward toward the open Atlantic, the world narrowed. Not in a dramatic, sharply defined way, but in a gradual tightening of space, a subtle drawing together of two massive pieces of the planet. Europe and Africa, immense in their own right, leaned toward each other across a strip of land and shallow passages that, for a time, acted as a quiet but powerful boundary between two very different worlds. If you picture this region in your mind, try not to imagine a clean, straight line on a map. Instead, think of a complex landscape shaped by hills, lowlands, rivers, and shifting ground. This was not a single wall holding back the sea. It was a patchwork of ridges, valleys, and shallow connections that rose and fell with the slow movement of the Earth's crust. On one side, the Atlantic Ocean stretched out deep and heavy, its surface rising and falling with tides and distant storms. On the other side, the Mediterranean basin lay far below, open, dry in many places, and shaped by evaporation and gravity. Between them, this narrow zone became the hinge on which the fate of an entire sea would eventually turn. Standing there, in that ancient landscape, you might have noticed how the air felt different depending on which direction you faced. Toward the west, the breeze would carry moisture, the faint tang of salt from the open ocean. Toward the east, the wind might feel drier, warmer, shaped by the vast exposed basin and the land that surrounded it. This meeting of air masses, like the meeting of land and water, made the region dynamic even in times of apparent stillness. The land itself was restless, though its movements were far too slow to be noticed in a single lifetime, or even in many lifetimes. Beneath the surface, tectonic plates pressed, slid, and shifted. The African plate moved steadily northward, pushing into the Eurasian plate. This slow-motion collision helped raise mountains in some areas and create low points in others. It bent and folded the crust, sometimes lifting land up, sometimes letting it sink. This constant, subtle motion is what shaped the narrow gate between the Atlantic and the Mediterranean. Over millions of years, the region was moulded by uplift and erosion, by the push of continents and the wearing down power of water and wind. Rivers that flowed toward the Atlantic cut valleys, rain softened slopes, gravity pulled loose rock downhill. Bit by bit, the landscape changed. What made this place especially important was its height, or rather, its relative lack of it. Even a difference of a few hundred meters could determine whether water flowed freely or was held back. In a world where the Mediterranean basin sat far below the level of the Atlantic, Any low point in this barrier became a potential doorway for the ocean, but for a long time that doorway remained closed. The Atlantic pressed up against the western side of the land, its waves rolling in, its tides rising and falling, but the water did not yet have a clear path through. The basin on the other side remained dry in many regions, its rivers still carving their way down toward a centre that lay far below sea level. This narrow region, then, existed in a kind of tension. It was a place of balance, holding back a massive difference in water level, like a dam made not of concrete, but of rock, soil, and the slow work of geological time. If you could have flown over it, looking down from high above you might have seen a varied terrain. Low-lying plains near the coast, higher ridges farther inland, winding river channels cutting through the landscape. Vegetation would have clustered around water sources, thinning out in drier areas. Animals would have moved along these natural corridors, following rivers, valleys and passes that offered easier routes across the land. From the perspective of life, this region was not just a barrier, it was a bridge. Plants and animals could move between continents here. Species from Africa and Europe found pathways through this narrowing space, spreading into new territories, adapting to different climates and conditions. Over long periods, this exchange helped shape the biological makeup of both sides of the Mediterranean world. So while from a physical standpoint this narrow gate held back an ocean, from a living standpoint it connected two great land masses. There's something quietly poetic about that dual role. The same stretch of land that prevented water from flowing freely allowed life to move and mix. The rivers in this region played an important part in both stories. Flowing from higher ground toward the Atlantic, they carried sediment, carved valleys, and sometimes eroded the very land that helped keep the ocean at bay. Every grain of sand they moved, every small rock they rolled downstream, was part of a much larger process of reshaping the barrier. Rainfall, too, had its say. During wetter periods, streams and rivers would swell, increasing their ability to cut into the landscape. During drier times, erosion would slow, and the land would hold its shape more stubbornly. Over thousands and tens of thousands of years, these cycles left their mark, gradually changing the height and strength of the narrow gate. You can imagine this as a long conversation between water and rock. Water, persistent and patient, always moving, always seeking the lowest point. Rock, solid and slow to change, but not immune to the steady pressure of flow, weather and gravity. In some places the land may have risen due to tectonic forces, even as rivers work to wear it down. In others, erosion may have outpaced uplift, creating lower and lower points in the barrier. The balance between these forces determined whether the Atlantic remained locked out or began to find a way in. What's striking is how close this region came, again and again, to tipping that balance. Geological evidence suggests that the connection between the Atlantic and the Mediterranean didn't simply close once and stay closed forever. It likely opened and narrowed multiple times over millions of years, allowing limited flows of water in some periods and cutting them off in others. Each time the connection weakened, a small amount of Atlantic water might have slipped through, raising the level of the basin slightly. Each time it strengthened, evaporation would once again begin to lower the water. The Mediterranean world lived in a kind of long-term fluctuation, its fate tied to the shifting shape of this narrow stretch of land. From the Atlantic side, the ocean itself was not a passive player. Waves battered the coast. Tides rose and fell. Storms pushed water inland. Over time, this constant motion also contributed to erosion, especially in lower-lying coastal areas. The sea worked at the edges of the barrier, just as rivers worked at it from above. If you stand on a modern coastline and watch waves crash against rock, you can see this process in miniature. A small crack fills with water. The water pushes in and out, carrying sand and pebbles. Over time, the crack widens. A small notch becomes a larger opening. Multiply that by thousands of years and a coastline can change dramatically. In the ancient narrow gate region, something similar was happening, just on a much larger scale. The climate of the time also influenced how all of this played out. Periods of higher rainfall meant stronger rivers and more erosion. Drier periods meant slower change. Shifts in global temperature affected sea levels, raising or lowering the Atlantic slightly and changing how much pressure it put on the land barrier. All of these factors combined to create a landscape that was never quite settled. It looked solid and stable on the surface, but beneath that appearance was a constant, subtle motion. There's a certain calmness in thinking about that kind of slow change. Nothing sudden, nothing dramatic, just the steady, quiet work of the planet shaping itself, grain by grain, layer by layer. And yet, within that calmness was the potential for something enormous. Because all it would take in the end was for the barrier to dip just low enough, or crack just wide enough for gravity to take over. The difference in height between the Atlantic Ocean and the Mediterranean basin was not trivial. It represented a huge amount of stored energy. Water at a higher level always wants to move to a lower one. When it does, it doesn't just flow, it accelerates, it gains speed, it gains power. So this narrow gate, for all its apparent simplicity, was holding back a force that, if released, would reshape an entire region in a relatively short span of time. It's interesting to think about how much of Earth's history hinges on places like this. Narrow connections, small gaps, shallow thresholds, points where a slight change can lead to a massive difference in outcome. In human terms, it's like a door that's almost, but not quite, open. A gentle push can make all the difference. For a long while, the door between the Atlantic and the Mediterranean remained just that. Almost open, not yet. Life continued on both sides. The basin remained largely dry in its centre. Rivers kept carving their deep channels. Salt continued to build up in thick layers. The Atlantic kept rolling against the western edge of the land, wave after wave, tide after tide. The narrow gate held. If you were to walk along this region during that time, you might notice subtle signs of strain in the landscape. Low areas where water pooled after heavy rains, valleys that seemed deeper than the surrounding terrain suggested they should be, slopes that showed signs of recent movement or collapse. But nothing, at least on the surface, would have told you that this place was about to become the site of one of the greatest floods in Earth's history. From a distance, it would have looked like just another stretch of land. Hills, plains, rivers, vegetation, animals moving through familiar patterns. It's a reminder that some of the most important places on the planet don't announce themselves with spectacle. They sit quietly, doing their job, holding a balance, until that balance shifts. As this narrow region continued to evolve, the pressure from the Atlantic never truly went away. The ocean didn't need to hurry. It had time on its side, millions of years if necessary, and the land, for all its strength, was always subject to the same slow forces that shaped mountains, valleys and coastlines everywhere else on Earth. Somewhere, deep within the rocks of this narrow gate, the story was being written in tiny fractures, in subtle shifts, in grains of sediment carried away by flowing water. The continents, immense and heavy, continued their slow approach and adjustment. The climate continued its long cycles of wet and dry. The sea level continued to rise and fall with global changes. The world remained in this state of near contact. Two continents almost touching. Two bodies of water held apart by a landscape that was slowly, quietly, being shaped by the very forces it was resisting. You can let that image settle in your mind. A narrow stretch of land, sunlit and windswept, standing between a full ocean and an empty basin. Rivers cutting into its surface, waves working at its edges, the ground beneath it shifting almost imperceptibly with the movement of the planet itself. There's a kind of quiet suspense in that scene, not the sharp kind that comes with ticking clocks or urgent deadlines, but a deep geological kind. The kind that unfolds over ages rather than minutes. Somewhere along that narrow stretch of land, in a place that would not have looked particularly special to anyone standing there at the time, the balance finally shifted. There was no announcement, no distant rumble to mark the moment, no sign in the sky or sudden change in the wind. Just a quiet, ordinary point on the landscape where rock, soil and water met in a slightly different way than they had the day before. You can imagine the surface of the land after a period of rain, small streams tracing paths across the ground, water gathering in shallow dips, following tiny cracks in the rock, most of it soaking in, evaporating, or flowing away without consequence. But in this particular place, gravity had been waiting for a long time, and now it had a path. The Atlantic Ocean, heavy and vast, sat just beyond the western side of this narrow region. Its surface lay far above the deep, empty Mediterranean basin on the other side. The difference in height between them was like a coiled spring storing energy simply by existing. All it needed was a release. When the land finally gave way, it may have started with something so small it would have been easy to miss, a thin trickle, a narrow stream slipping over a low point in the barrier. The first Atlantic water in a very long time beginning its journey eastward, drawn downward by the immense drop beyond. That first flow didn't look like a flood. It probably looked like a river. Water spilled over the edge and began to run downhill, gathering speed as it went. As it moved, it picked up grains of sand, small stones, bits of soil. Those particles, carried along in the current, acted like tools, scraping and cutting at the surface beneath them. The path grew wider, the flow grew faster, the river deepened its own channel as it went. This is one of water's quiet talents. It doesn't just follow a path, it makes one. Every second that water moved, it changed the land slightly. The faster it flowed, the more it could carry. The more it carried, the more it could erode. The more it eroded, the wider and deeper the channel became, and as the channel grew, even more water could pass through. It was a feedback loop, simple in concept, powerful in effect. At first, the Atlantic water that crossed into the Mediterranean basin would have fallen down a steep slope, perhaps forming a series of cascades or a growing waterfall. Below, the basin floor lay far beneath, waiting to receive it. The drop was not gentle. It was dramatic, like a river suddenly discovering a cliff. You can picture the sound building. At the beginning, it might have been a quiet rush, the kind you hear from a stream running over rocks. But as the flow increased, the noise would have deepened and grown. A steady roar, echoing off the surrounding land, carrying across the empty basin. This was the moment when water stopped being just water and started becoming a force. The more Atlantic water poured through, the more the land gave way. What began as a narrow channel became a widening gap. The gap became a gorge. The gorge became a massive opening that could carry an ocean's worth of flow. Scientists today try to reconstruct this moment by looking at the shapes carved into the seafloor and the rocks around the Strait of Gibraltar. There are features that suggest the passage of enormous volumes of fast-moving water, channels too large to be explained by ordinary rivers, erosion patterns that point to something sudden, powerful, and sustained. As the opening widened, the Atlantic no longer had to squeeze through a narrow path. It could surge. Imagine standing on the edge of the basin at this point. Looking west, you would see a growing wall of water, not in the sense of a single towering wave, but in the sense of a continuous, relentless flow. A wide, fast-moving river of ocean water pouring over the land and down into the deep basin below. The scale of it is difficult to hold in the mind. This wasn't a flood that covered a valley or spilled across a plain. This was a process that began to refill an entire sea. Estimates vary, but many scientists believe the water level in the Mediterranean basin may have risen by several meters per day during the peak of this event. That's not a gentle change, that's a visible one. If you were somehow there, standing on a ledge above the basin floor, you might have been able to watch the shoreline move, hour by hour, creeping upward along the slopes. The water didn't arrive quietly. It would have churned and foamed as it fell, carrying air with it, creating turbulence and waves that spread outward across the growing body of water. As the basin began to fill, currents formed, swirling and colliding, shaping the surface into moving patterns. Below the surface, sediment that had settled during the dry period was stirred up and carried along. Fine particles of salt, clay and sand mixed into the water, creating clouds that drifted and settled in new places. The returning sea was not clear and calm. It was active, dynamic and full of motion. This wasn't just water moving into an empty space. It was water meeting a landscape that had been shaped for dryness. Cliffs that had once stood high above a dry basin now found themselves at the edge of rising water. Slopes that had been carved by rivers and wind began to disappear beneath waves. Valleys that had guided streams now became underwater channels. As the level rose, the behaviour of the incoming water changed. At first it fell steeply, driven by gravity. But as the basin filled, the difference in height between the Atlantic and the Mediterranean began to shrink. The drop became less dramatic. The flow became broader, more like a massive river pouring into a growing lake. This change didn't stop the flood, but it did alter its character. The violent descent of water gave way to a powerful, sustained inflow that continued until the two bodies of water reached a new balance. The timescale of all this is still a subject of research and debate. Some estimates suggest that the main phase of the refill could have taken place over a few months to a couple of years. Others allow for a somewhat longer period. Either way, in geological terms, it was incredibly fast. To the Earth, which measures its history in millions and billions of years, this was a sudden event. A sharp, dramatic line in the layers of rock and sediment, a before and an after. As the water advanced across the basin, it didn't move as a perfectly smooth front. The shape of the land influenced everything. High points became islands. Low areas filled first, forming deep pools that gradually expanded and connected. Ridges and slopes guided currents, creating complex patterns of flow. Some areas may have experienced powerful waves as the incoming water collided with the basin's walls and reflected back. These waves would have travelled across the surface of the growing sea, reshaping shorelines as they went. The air above the basin would have changed too. The sudden presence of a large body of water affects temperature and humidity. Moisture would have begun to rise into the atmosphere, forming clouds, altering local weather patterns. Rainfall in surrounding regions may have increased as the new sea began to influence the climate. Life, if it had been present near the edges of the basin, would have faced a rapidly changing world. Plants growing on low-lying ground would have been overtaken by water. Animals would have had to move upslope, retreating as the shoreline climbed. Freshwater habitats would have been transformed into brackish or salty environments. Marine life, on the other hand, had an opportunity to return. As Atlantic water poured in, it carried with it microscopic organisms, larvae and nutrients. Over time, these would help re-establish a marine ecosystem in the newly forming sea, but in the earlier stages the environment would have been chaotic. Changing salinity, shifting currents and suspended sediment would have made conditions challenging for many forms of life. The sea, in its return, went through a kind of turbulent infancy before settling into a more stable state. There's a powerful contrast in this moment between the quiet waiting that came before and the sudden motion that followed. For thousands of years, the basin had existed in a relatively steady condition, defined by sun, salt, and slow change. And then, in what may have been less than a human lifetime, water transformed it into something entirely different. It's a reminder that not all change is gradual. Some of the most dramatic shifts in Earth's history happen when a threshold is crossed. That threshold in this case was the narrow gate between the Atlantic and the Mediterranean. Once the water found a way through, it didn't hesitate. If you imagine the flow from above, you might see something like a broad, bright ribbon of moving water cutting through the land, widening as it goes, emptying into a basin that grows darker and deeper with each passing day as its water level rises. The edges of this ribbon would be in constant motion. Landslides could occur as the ground near the channel became saturated and unstable. Sections of the barrier might collapse, adding even more material to the flow, further widening the opening. All of this would have fed into the same cycle. More opening meant more water meant more erosion. More erosion meant an even larger opening. This kind of runaway process is one of the reasons scientists believe the refill happened so quickly. From a human perspective, it's difficult to imagine something of this scale. We're used to thinking of floods as events that affect cities, rivers, or regions. This was a flood that affected a sea. The volume of water involved was immense. The Atlantic Ocean didn't noticeably lower because of it, but the Mediterranean basin rose dramatically. As the level climbed, the shape of the basin began to resemble what we recognise today. Shorelines formed along the edges of the surrounding continents. Currents began to circulate within the growing sea. The surface became a wide, open expanse of moving water reflecting the sky above. Eventually, the difference in height between the Atlantic and the Mediterranean became small enough that the flow slowed. The system reached a new balance. The narrow gate became a strait, a connection rather than a barrier. Water moved in and out with tides and currents instead of pouring in one direction. The flood, in that sense, came to an end. But its effects didn't stop there. The layers of sediment stirred up and redeposited during the refill created new geological records. The shapes carved into the land remained. The return of marine conditions set the stage for the development of ecosystems that would evolve over millions of years into the rich and diverse Mediterranean world we know today. What's especially striking is how much of this story is written into the earth in a way that doesn't require imagination alone. Scientists can drill into the seafloor and find the thick salt layers that formed during the dry period. They can map underwater valleys and channels that point to massive flows of water. They can analyse the chemistry of rocks and sediments to piece together changes in salinity and temperature. Each of these pieces acts like a sentence in a much larger story, one that tells of absence and return, of stillness and motion. As you sit with this moment, the first drop that changed everything, it's worth noticing how often big changes in our own lives start the same way. Not with a dramatic event, but with a small shift, a decision, a chance meeting, a quiet moment that opens a new path. Of course, the scale here is very different, but the pattern, in a way, is familiar. The land didn't collapse all at once. The ocean didn't surge through in a single wave. It began with a path, and once that path existed, the rest followed. The Earth in this moment was not acting with intention or awareness. It was simply following the rules that govern water, rock and gravity. But the result, when viewed from our perspective millions of years later, feels almost like a story with a turning point. Before, there was a basin without a sea. After, there was a sea without a basin. And between those two states, there was a narrow gate and a first flow of water that grew into something powerful enough to reshape a region of the planet. As the Mediterranean continued to fill, the character of the flood changed from a dramatic descent to a broad, steady inflow. The roar of falling water would have softened into the constant lower sound of a massive river-like current. The basin's surface would have smoothed out, even as currents and waves continued to move beneath the sky. Over time, the landscape settled into a new kind of quiet. Not the dry, windswept stillness of before, but the open, rolling calm of a sea. But even as that new calm took shape, the marks of the flood remained. In the depths, in the layers of rock, in the contours of the land hidden beneath the water. Those marks are still there today, beneath ships and sunlight, beneath currents and coastlines, telling the story of how, once upon a deep stretch of geological time, water found a way. Long after that first narrow path widened into a broad, unstoppable channel, the world at the western edge of the Mediterranean basin entered a phase that defies easy comparison. The Atlantic was no longer simply finding a way in, it was pouring, descending and reshaping the planet in a way that, even millions of years later, still leaves its signature carved into stone and hidden beneath layers of water and sediment. To understand what this moment might have been like, it helps to step away from everyday ideas of waterfalls. We're used to thinking of them as features you can walk up to, hear over the sound of wind and birds, maybe feel as a fine mist on your face. But the cascade that formed at this narrow gate was not a scenic landmark. It was a moving boundary between two worlds, stretching across kilometres of land, dropping water from the level of a global ocean down into a basin that sat far below. The difference in height between the Atlantic and the Mediterranean basin at this time is estimated to have been on the order of hundreds of metres, possibly more in some areas. That's not a cliff you'd find on a hiking trail. That's the kind of vertical distance that rivals mountain faces, and instead of a thin ribbon of water slipping over the edge, this drop carried a flow wide enough to resemble a river the size of a small sea. If you imagine standing somewhere nearby, which is already a stretch of the imagination, the first thing you would likely notice is not what you saw, but what you heard. The sound would have been continuous and immense, not a crashing roar that rises and falls with individual waves, but a deep, sustained presence, like the planet itself was exhaling. The air would have vibrated with it. Low-frequency sound travels far, and a cascade of this size would have sent a constant rumble across the surrounding landscape. It might have been audible from dozens, perhaps even hundreds of kilometres away, depending on the terrain and the atmosphere. A kind of background note to the world day and night, as long as the flow continued. The visual would have been just as striking. A wide front of moving water, breaking into white and grey as it fell, throwing spray into the air that caught the sunlight and scattered it in shifting patterns. Mist would have risen in thick clouds near the base of the drop, drifting with the wind and settling back onto the land in a fine, salty veil. Below the falling water, the basin would have been a place of constant motion. The impact of that much mass hitting the surface of the growing sea would have created powerful currents, churning the water and stirring up sediment from the floor. Waves would have radiated outward from the point of impact, travelling across the basin and reflecting back from distant shores that were themselves slowly moving as the water level rose. This wasn't a single neat waterfall. The shape of the land meant that the flow likely split into multiple channels and cascades, changing over time as erosion reshaped the edges of the opening. One day, a particular section of the barrier might hold. The next, it might collapse, adding another segment to the descending front of water. Each collapse would have been a dramatic event in its own right. Tons of rock and soil breaking free, sliding and tumbling into the flow, carried away or ground down by the force of the water. The channel would widen, deepen, and change shape almost in real time, at least on a geological scale. From above, if such a viewpoint were possible, the scene might have looked like a massive bright scar across the landscape, a wide shifting line where the Atlantic met the land and then dropped away into the depths of the basin. The contrast between the dark blue of the ocean, the lighter tones of the falling water, and the dusty pale colours of the surrounding rock would have been stark and dramatic. But what makes this moment even more remarkable is not just how it looked or sounded, but how much energy it represented. Water has weight. A lot of it. When you move an ocean's worth of water downhill, even by a few hundred metres, you're releasing an enormous amount of gravitational potential energy. That energy doesn't disappear. It becomes motion, turbulence, sound, heat, and erosion. In a sense, this cascade was one of the largest natural energy transfers on the planet at the time, not in a sudden, explosive way like a volcanic eruption or a meteor impact, but in a sustained, relentless way. A continuous conversion of height into movement, day after day, month after month. This is part of what made the refill of the Mediterranean basin so fast by geological standards. The system didn't just rely on a slow, gentle flow. It was driven by a powerful drop that kept pulling water in at high speed until the difference in height between the two bodies of water was significantly reduced. As the basin filled, the height of the drop gradually decreased. The waterfall, if you want to call it that, slowly shrank. The sound would have softened over time. The mist would have become less dramatic. The flow would have broadened and smoothed out, transitioning from a roaring descent to a strong, steady current. But during its peak, this feature would have been one of the most dominant elements in the landscape. It's interesting to think about how this constant sound and motion might have shaped the surrounding environment. The air near the cascade would have been humid and salty, a sharp contrast to the dry, sun-baked basin that existed before. Plants in the area might have adapted to this new source of moisture. Soils would have changed as salt spray and fine sediment settled out of the mist. Weather patterns could have been influenced as well. A large moving body of water and a continuous source of airborne moisture can affect cloud formation and local winds. The returning sea was not just filling a hole in the land, it was beginning to interact with the atmosphere in ways that would ripple outward across the region. Below the surface of the growing Mediterranean, the story was just as active. The impact of the falling water would have created strong downward currents, pushing oxygen-rich surface water into deeper layers. This mixing could have influenced temperature and salinity gradients, setting the stage for the circulation patterns that would later define the sea. Sediment carried in by the flood would have settled in layers across the basin floor, creating a new geological record. Coarser material would have dropped out closer to the point of entry, while finer particles would have been carried farther, spreading out in thin blankets across wide areas. These layers, stacked on top of the thick salt deposits from the dry period, form a kind of natural archive. By drilling into them, scientists can read the sequence of events, seeing the transition from evaporation to influx, from stillness to motion, preserved in alternating bands of different materials. From a distance in time, this part of the story can feel almost abstract. Numbers, estimates, layers of rock. But if you bring it back to the scale of experience, it becomes something more tangible. Imagine trying to sleep within earshot of a waterfall that never stops, a sound that doesn't fade with night or soften with distance, a presence that fills the air and becomes part of the background of everything else. For the landscape itself, this would have been a defining feature for as long as the cascade remained strong. Animals in the area would have had to adjust. Some might have avoided the noise and mist. Others might have been drawn to the water and the new vegetation that grew nearby. Birds could have used the rising air currents created by the moving water to soar and glide. Life, as always, would have found ways to adapt to the new conditions. What's especially striking is how this immense dramatic feature was also temporary. On a human timescale, it would have seemed eternal. A waterfall taller than mountains pouring day and night. But on a geological timescale, it was a phase, a chapter in the planet's long story. As the Mediterranean basin filled, the drop that drove the cascade diminished. The energy that powered it slowly faded. The roar softened. The mist thinned. The flow spread out. Eventually, the dramatic descent gave way to something more familiar. A strait. A connection between two seas. Water moving in and out with tides and currents, rather than plunging in one direction under the pull of gravity. The landscape around the former cascade would have continued to change. The eroded channel would have been reshaped by calmer flows. New sediments would have settled. Over time, the raw, freshly carved features would have softened. But even as those surface details changed, the deeper marks remained. The shape of the seafloor near the Strait of Gibraltar still hints at the massive flows that once passed through. Submerged channels and eroded surfaces point to a time when water moved not as a gentle current, but as a powerful, sustained flood. There's something quietly awe-inspiring about that. The idea that a feature so dramatic, so loud, so energetic could come and go, leaving behind only subtle clues for future minds to piece together. It's also a reminder of how much of Earth's history happens without witnesses. No one stood there to marvel at the sight. No one wrote down descriptions or tried to capture the sound. The planet did what it does, and only later did creatures like us arrive, curious enough to ask what happened. As you think about this waterfall taller than mountains, it's worth noticing how it changes your sense of scale. Mountains, which we often think of as the ultimate symbols of size and permanence, become reference points for something that was, in a way, even more dynamic. Not solid and unchanging, but moving, flowing, and reshaping itself from moment to moment. The sound the Earth could never forget in that sense is not just the literal noise of falling water, it's the memory of motion written into rock, into sediment, into the shape of a sea. Even today, long after the cascade has vanished, the Mediterranean and the Atlantic still exchange water through the Strait of Gibraltar. Currents flow in at the surface and out at depth, driven by differences in salinity and temperature. It's a quieter, more balanced system, but it's still a conversation between two bodies of water. That conversation began, in its current form, with this dramatic event, with a time when the difference between high and low was so great that the planet answered with a flood. If you let your mind linger there, at the edge of that ancient drop, you might picture the scene in slow motion. Water gathering at the brink, the surface bending and folding as it tips over, the long fall, the burst of spray at the bottom, the spreading ripples across a growing sea. There's a rhythm to it, even in its intensity, a constant steady movement, not rushed, not hesitant, just following gravity's simple instruction to go down. In that way, the cascade becomes a kind of natural metronome for the planet, a marker of a transition, a way of measuring the shift from one state of the world to another. Before, there was a dry basin and a closed gate. After, there was a sea connected to an ocean. Between those two states, there was this moment of sustained motion, this waterfall that reshaped a region. As the flow continued and the basin filled, the Earth moved into the next phase of the story. The stage of rising shorelines, forming currents, and the gradual settling into a new, stable sea. The roar, the mist, the churning water, all of it began to fade into memory, preserved only in the layers beneath the waves. But the impact of that sound, in a broader sense, never really went away. It lives on in the shape of coastlines, in the chemistry of the water, in the ecosystems that grew from the returning sea. And as you listen now, in a world where that ancient cascade has long since stilled, it's quietly present in the fact that the Mediterranean exists at all, that there is a sea where once there was a basin beneath the sun. The Earth doesn't keep recordings, it keeps records. In rock, in salt, in sediment, and in the slow, steady patterns of the planet itself. The waterfall taller than mountains is gone, but its story is still flowing, carried forward in every wave that rolls across the Mediterranean surface, and in every current that slips through the narrow gate where two continents almost touch. As the great descent of water continued and the Mediterranean basin rose toward its modern form, something subtle but far-reaching began to happen, beyond the roar of the falling Atlantic and the churn of the growing sea. The flood was not only changing what lay below, it was also changing what moved above. The air itself became part of the story, shaped by the sudden presence of a vast moving body of water where there had once been open, dry land. If you imagine standing on one of the surrounding slopes during this time, you might have felt the difference long before you fully saw it. The breeze would have carried a new weight. The air would have felt cooler in some moments, heavier in others, carrying moisture that hadn't been there before. Clouds would have begun to form more readily, gathering and thickening as warm air rose from the warming land and met the cooler air above the growing sea. This is where the idea of rivers in the sky begins to make sense. Large bodies of water don't just sit quietly beneath the atmosphere, they feed it. Sunlight warms the surface, water evaporates, and invisible vapour rises into the air. That vapour doesn't stay still. It moves with winds, following invisible pathways shaped by temperature differences, pressure systems, and the shape of the land. As the Mediterranean returned, it became a new source of moisture for the region, a wide, shimmering surface sending water upward into the sky, where it could travel hundreds or even thousands of kilometres before falling back to Earth as rain. Before the flood, the basin's influence on the atmosphere would have been very different. Dry land reflects and releases heat in a different way than water. It doesn't provide the same steady source of moisture. The air above it tends to be drier, and cloud formation can be more limited, especially in regions already prone to warm, arid conditions. But once the basin began to fill, the balance shifted. Warm air rising from the water's surface carried moisture upward, where it cooled and condensed into clouds. Winds picked up these clouds and moved them across the surrounding continents. Rain began to fall in patterns that hadn't existed before, reshaping the land far beyond the immediate reach of the flood itself. In this sense, the returning Mediterranean didn't just redraw coastlines, it rewrote the behaviour of the sky. Rivers on the ground felt this change almost immediately. Increased rainfall in some regions meant stronger flows. Streams that had once trickled now surged more often. River valleys deepened. Floodplains expanded. Sediment carried from hills and mountains was deposited in new places, building up deltas and reshaping lowlands. This is one of the quieter but more powerful ways landscapes change. Not through a single dramatic event, but through the steady repetition of water moving downhill, carrying pieces of the land with it. As rainfall patterns shifted, so did vegetation. Plants that thrived in drier conditions gave way in some areas to species that preferred more consistent moisture. Forests expanded in certain regions. Grasslands and wetlands formed in others. The distribution of life across southern Europe, North Africa, and the Middle East began to take on a new character, influenced by the presence of a sea that had only recently returned. The flood, in this way, acted like a kind of environmental reset. Not in the sense of erasing everything that came before, but in the sense of changing the rules of the system. The inputs changed, and so the outputs followed. What's fascinating is how far these effects could reach. Moisture that evaporated from the Mediterranean surface could travel deep into continental interiors. It could rise over mountain ranges, cool and fall as snow on high peaks. That snow in turn would melt in warmer seasons, feeding rivers that flowed back toward the sea or toward entirely different bodies of water. The flood created loops. Water rose from the sea, travelled through the sky, fell on the land, and returned to the sea through rivers. The basin that had once been a sink for water, a deep, dry depression drawing rivers inward, became part of a broader, more dynamic cycle. This is where the idea of rivers in the sky becomes more than a metaphor. The atmosphere began to carry streams of moisture, guided by wind patterns, forming invisible pathways that connected the Mediterranean to distant regions. These pathways are influenced by large-scale atmospheric circulation, such as prevailing winds and pressure systems. The shape of the land matters too. Mountains can force air to rise, causing moisture to condense and fall as rain on one side, while leaving the other side drier. As the Mediterranean returned, it added a new player to this system, a broad source of warmth and moisture that interacted with existing patterns, nudging them, reshaping them, and in some cases, amplifying them. The result was a landscape in motion, not just at the level of coastlines and seafloors, but across entire regions. If you look at the modern Mediterranean world, you can see hints of this influence. The climates of southern Europe, North Africa, and parts of the Middle East are shaped by the presence of the sea. Coastal regions tend to have milder temperatures and more consistent rainfall than inland deserts or high mountain areas. Winds carry moisture from the sea toward the land, supporting forests, agriculture, and diverse ecosystems. This wasn't always the case. During the dry basin period, the interior regions around the Mediterranean would have experienced more extreme conditions in many places. The return of the sea softened some of those extremes. From the perspective of the land, this change played out in the slow language of erosion and deposition. Hills and mountains began to shed material more actively as rainfall increased. Soil was carried downhill. Rivers cut deeper into their beds. Valleys widened. Over time, this reshaping altered the very outline of the continents around the Mediterranean. It's worth pausing here to consider how different this kind of change is from the dramatic waterfall that poured into the basin. That cascade was loud, fast, and visually striking. The atmospheric and landscape changes that followed were quieter, but in many ways just as powerful. A single flood can fill a sea, but shifting rainfall patterns can reshape entire regions over millions of years. This process doesn't leave a single, obvious mark. Instead, it leaves a web of subtle clues. The shape of a river valley, the thickness of soil in a particular region, the distribution of plant species across a landscape. Each of these tells part of the story of how water has moved, not just on the ground, but through the air. As the Mediterranean stabilised, currents within the sea itself also began to influence the atmosphere. Warm water near the surface released heat into the air, while cooler water at depth absorbed it. This exchange helped drive local wind patterns, especially along the coasts. Sea breezes developed, blowing from the water toward the land during the day as warm air rose over sun-heated ground, and reversing at night as the land cooled more quickly than the sea. These daily rhythms added another layer of motion to the system, another set of gentle, repeating flows that shape the environment. In mountainous regions, this interaction became even more complex. Moist air rising from the sea could be forced upward by slopes, cooling and dropping its water as rain or snow. This process, known as orographic precipitation, can create lush, green regions on one side of a mountain range and dry, shadowed areas on the other. Over long periods, this difference in moisture availability can lead to stark contrasts in vegetation, soil development, and even the types of animals that live in neighbouring regions. All of this began, in a sense, with the return of the sea. It's interesting to think about how much of what we see today traces back to that moment, not in a direct, simple line, but through a chain of influences. The flood changed the sea changed the air changed the rain changed the land changed the living things that grew on it. When you look at a map of the Mediterranean region now, with its patchwork of forests, deserts, farmlands and cities, you're seeing the result of countless such interactions layered on top of one another over millions of years. The phrase rewrote the shape of the land doesn't just refer to coastlines and seafloors. It refers to this entire network of cause and effect. Even the great rivers of the region felt the influence. The Nile, flowing northward through Africa into the Mediterranean, carries water and sediment from deep within the continent. Changes in rainfall patterns across its vast drainage basin can alter its flow, its flooding behaviour, and the fertility of the land along its banks. As the Mediterranean returned and began to influence regional climate, systems like the Nile would have adjusted over time. The same is true for rivers in southern Europe, such as those flowing from the Alps or other mountain ranges toward the sea. These rivers became part of a new equilibrium, shaped by the presence of a stable, open body of water at their destination. Below the surface of the Mediterranean, the story continued in another form. The circulation of water within the sea began to establish patterns that influenced temperature and salinity. Surface water entering from the Atlantic mixed with the more saline water of the Mediterranean, creating layers and currents that moved through the basin. These currents in turn influenced how heat was distributed within the sea. Warmer and cooler regions formed, affecting evaporation rates and, by extension, the amount of moisture entering the atmosphere above. So even the internal dynamics of the sea fed back into the behaviour of the sky. This kind of interconnectedness can feel almost overwhelming when you try to follow it all. A change in one part of the system ripples outward, touching many others. But there's also something calming about it. The idea that the planet operates as a whole, with land, water and air constantly in conversation. In the quiet hours of the night, when everything around you feels still, it can be comforting to remember that, on a larger scale, the Earth is always moving, always adjusting, always finding new balances. The flood that refilled the Mediterranean was a dramatic example of that adjustment, but the rivers in the sky that followed were a gentler, ongoing expression of the same process. If you let your imagination wander back to that time, you might picture clouds forming over the growing sea, thick and white against a blue sky. You might see them drifting inland, darkening as they gather more moisture, then releasing it in long, steady rains over distant hills and plains. Those rains would send water trickling down slopes, joining streams, feeding rivers that carried the water back toward the sea. The cycle would repeat day after day, season after season. Over years, those small flows would carve channels. Over centuries, they would deepen valleys. Over millennia, they would shape entire landscapes. This is how the flood's influence extended far beyond the basin itself. It reached into the heart of continents, not with a wall of water, but with a steady, persistent rain. There's a quiet beauty in that contrast. The same event that created a roaring cascade at the narrow gate also set in motion these gentle, skyborne rivers that whispered across the land. Both are expressions of the same underlying force, water responding to energy, to gravity, to heat. As the Mediterranean settled into its new role as a stable sea, these atmospheric patterns became part of the background rhythm of the region. They no longer announced themselves as something new or dramatic. They simply became the way things were. But beneath that apparent normality lies a history of change. The hills, valleys and coastlines you might see today around the Mediterranean are, in part, the result of this long interplay between sea and sky, land and rain. Each layer of soil, each bend in a river, each patch of forest carries a trace of that story. If you were to walk through a modern Mediterranean landscape, you might not think about clouds as rivers or rain as a kind of return flow, but in a broader sense that's exactly what they are. Water lifted from the sea, carried across the sky, and returned to the land, shaping it piece by piece. The flood in this way never truly ended. It changed form. The dramatic rush of water through the narrow gate gave way to a slower, more widespread movement through the atmosphere. The basin filled, but the cycle continued. And as the land adjusted to this new reality, it began to settle into patterns that would persist for millions of years. The shape of coastlines became more stable. Ecosystems found their niches. Climates developed their characteristic rhythms of wet and dry, warm and cool. All of this flowed, in one way or another, from the moment when water found a way and then poured, fell, and rose into the sky. As you listen now, you might notice the air around you, the faint sound of wind, the feeling of humidity or dryness on your skin, the way clouds move across the sky, even if you can't see them from where you are. Those small, everyday experiences are part of the same planetary system, the same endless conversation between sea, land, and air. The Mediterranean flood was an extreme example, a dramatic punctuation mark in that conversation. But the dialogue itself never stops, and as the planet continues to move, to warm, to cool, to shift and settle, the rivers in the sky keep flowing, quietly carrying water from one place to another, reshaping the world in ways that are easy to overlook in the moment, but impossible to miss when you step back and look across deep time. At some point during this extraordinary period, the Mediterranean basin crossed a quiet but profound threshold. It stopped being a place defined by incoming water and became a place defined by rising water. The difference might sound subtle, but in terms of what the land, the sky, and the living world experienced, it marked a shift from motion, at a gateway to motion across an entire region. The sea was no longer something happening at the edge. It was something happening everywhere. If you imagine standing on one of the slopes that once looked out over a wide, dry basin, the view would have changed day by day in a way that is almost impossible to picture with modern experience. Most coastlines we know move slowly, a few centimetres a year here, a metre or two over decades in places where erosion or deposition is active. The idea of a shoreline that visibly advances within a single lifetime feels strange, and yet during the peak of the Zanclean Flood, the Mediterranean's edge may have done exactly that. Estimates suggest that in some phases the water level rose by several metres per day. Even if that number is at the high end of what actually occurred, the overall picture remains the same. This was not a gentle, creeping return of the sea. It was a fast, relentless climb. Picture a valley that had once carried a river toward the centre of the basin. For thousands of years, water flowed down its channel, carving it deeper, shaping its sides. Now, instead of a river running downhill, a sea began to move uphill into that same space. The lower sections of the valley would fill first, becoming narrow inlets or fjord-like arms of the rising Mediterranean. As the level climbed, those inlets would lengthen, pushing farther and farther inland. Cliffs that had once stood high above dry land would find themselves at the water's edge, and then, not long after, partly submerged. High points would turn into islands, at least temporarily, standing alone in a growing expanse of water, until the sea climbed high enough to connect them back to the mainland. This process didn't happen uniformly across the entire basin. The shape of the land determined everything. Low-lying areas filled quickly, becoming deep pools that spread outward. Higher ridges resisted longer, creating complex branching shorelines with bays, peninsulas, and isolated pockets of water. From above, the rising sea would have looked like a living thing, spreading across the basin in uneven patterns, guided by the contours of the terrain. In some places it would rush forward, flooding wide, flat areas. In others, it would inch along narrow valleys and steep slopes. There's something both dramatic and strangely quiet about that image. No single, towering wave sweeping across the land, just the steady, persistent advance of water, hour after hour, day after day. For the land itself, this was a time of rapid adjustment. Slopes that had been stable under dry conditions became unstable when saturated. Landslides could occur as water seeped into cracks and layers of sediment, reducing friction and allowing gravity to pull material downward. These collapses would add sediment to the rising sea, muddying the water and changing the shape of the newly forming seafloor. In places, entire sections of hillside might slump into the water, creating underwater terraces and ridges that would remain hidden beneath the surface long after the flood ended. The speed of the rising sea also meant that many of the features carved during the dry period were quickly drowned. Deep river canyons became submerged valleys. Salt flats disappeared beneath layers of water and sediment. The sharp contrasts of the dry basin softened as everything became part of a continuous underwater landscape. This process left behind a complex seafloor shaped by both air and water. Some features were carved by rivers and wind, others were shaped by waves and currents. Together, they formed a kind of hybrid terrain, a record of two very different environmental states layered on top of each other. As the water level climbed, the behaviour of the flood changed again. Early on, much of the energy was focused at the narrow gate, where water fell into the basin. But as the basin filled, the overall drop between the Atlantic and the Mediterranean decreased. The waterfall-like flow softened into a powerful but more even current. The system began to approach something closer to balance. Water still flowed in, driven by differences in salinity and density, but the dramatic height-driven surge faded. Even so, the rising sea itself remained the most noticeable feature of the landscape. If you imagine standing on a hillside overlooking the basin, you might have marked the shoreline mentally, day after day. A rock that was dry one morning might be surrounded by water a few days later. A patch of vegetation near the edge might disappear beneath the surface. The world would feel like it was slowly, steadily being claimed by the sea. This kind of change would have been deeply unsettling for any life in the area. Plants rooted in low-lying ground would have had no way to escape. Animals would have been forced to move upslope, following the retreating edge of dry land. Migration routes would have shifted. Habitats would have fragmented and reformed in new places. Freshwater environments such as river mouths and temporary lakes would have been especially affected. As salt water advanced, it would mix with fresh water, creating brackish conditions that only some species could tolerate. Over time, fully marine conditions would take over. This transition zone between land, river and sea is often one of the most dynamic and biologically rich environments. During the flood, it would have been in constant motion, shifting day by day as the water level rose. The rising sea also began to influence the shape of the atmosphere above it more strongly. A larger surface area of water meant more evaporation, more moisture in the air, and more potential for cloud formation. The climate of the surrounding regions continued to adjust, responding to the growing presence of the sea. In some areas, increased rainfall would have led to stronger river flows, which in turn carried more sediment into the basin. This sediment would settle out as the water slowed near the edges, building up new deltas and underwater fans. These features, formed at the meeting point of land and rising sea, would become important parts of the seafloor structure. They also played a role in shaping future coastlines once the sea reached a more stable level. From a geological perspective, this period of rapid sea level rise is a kind of signature event. It leaves behind distinctive layers of sediment, marking a sharp transition from dry evaporative conditions to wet, marine ones. If you were to drill down through the seafloor today, you would pass through thick layers of salt and minerals from the dry basin period, and then suddenly encounter different kinds of sediments deposited by the returning sea. That boundary is like a line in a book, separating two very different chapters of Earth's story. What makes this moment especially remarkable is how it compares to other sea level changes in Earth's history. Over the past few million years, global sea levels have risen and fallen many times, driven by the advance and retreat of ice sheets during ice ages. Even those changes, which can involve tens or even over 100 meters of sea level difference, typically unfold over thousands of years. The Zanclean Flood stands out because of how concentrated and rapid it appears to have been. Instead of a slow global process, this was a regional event driven by a dramatic topographic difference and a sudden reconnection between two bodies of water. In a way, it was like pulling the plug on a giant bathtub that had been sitting empty for a very long time, except in reverse. Instead of draining, it was filling. And instead of a faucet, the source was an entire ocean. This analogy only goes so far, of course. The scales involved are vastly different, but the idea of stored potential, suddenly released, captures something essential about the process. The basin, sitting far below sea level, represented a kind of gravitational invitation. Once the path opened, the Atlantic accepted. As the sea rose, the character of the landscape continued to evolve. The complex network of valleys and ridges carved during the dry period became a maze of underwater features. Some of these would later influence ocean currents, creating areas of upwelling or turbulence that affected marine life. The shape of the seafloor matters because it guides how water moves above it. Currents tend to follow channels and avoid obstacles. Where water is forced upward, nutrients from deeper layers can be brought to the surface, supporting plankton and, in turn, larger forms of life. So even in the early stages of the Mediterranean's return, the foundations were being laid for future ecosystems. There's a kind of quiet continuity in that. The flood wasn't just an end to a dry period. It was the beginning of a long, complex process of biological and environmental development that would continue to unfold for millions of years. From a human perspective, it's tempting to focus on the drama of the rising water. The idea of a sea that climbs meters per day feels almost cinematic. But from the perspective of the planet, it was simply another adjustment. A rapid one, yes, but still part of the same ongoing pattern of change. As the basin filled, the surface of the water began to reflect the sky in broader, smoother expanses. The churning near the entry point gradually gave way to calmer conditions farther from the narrow gate. Waves formed, driven by wind rather than by the force of falling water. These waves began to work on the new shorelines, eroding some areas, depositing material in others. Beaches started to form in places where sediment accumulated. Rocky coasts developed where harder materials resisted erosion. The Mediterranean in this sense was learning how to be a sea again. There's something almost developmental about that idea, a system emerging from a dramatic birth into a more stable, self-regulating state. As this happened, the difference between the Atlantic and the Mediterranean continued to shrink. The height-driven flow weakened, replaced by a more complex exchange driven by differences in salinity, temperature and density. Even today, this exchange is visible. Less salty Atlantic water flows into the Mediterranean at the surface, while saltier, denser Mediterranean water flows out at depth. It's a two-way conversation, a far cry from the one-way rush that defined the flood. But that quieter system rests on the foundation laid by the rapid rise. The speed of the sea's return also had implications for how the basin's interior adjusted. Water pressure increased quickly, affecting the sediments and rock layers beneath. In some areas, this could have triggered the release of trapped fluids or gases, further altering the seafloor. These kinds of processes are still studied today, as scientists try to understand how sudden changes in water load can influence geological stability. From a distance in time, it's easy to see this period as a single event, but when you slow it down, it becomes a series of moments, a shoreline moving, a valley filling, a ridge becoming an island and then disappearing beneath the surface, a river mouth turning into a bay. Each of those moments represents a small change in a much larger transformation. If you were to follow the rising sea across the basin, you would see different stories playing out in different places. In one region, water might spill across a wide plain, creating a shallow, expansive area. In another, it might snake through a narrow canyon, forming a deep, winding inlet. The variety of these environments would have influenced how marine life recolonized the basin. Some species prefer shallow, sunlit waters. Others thrive in deeper, cooler regions. The complex, rapidly changing landscape would have created a patchwork of habitats. Over time, this diversity of conditions would contribute to the rich biological character of the Mediterranean, which today supports a wide range of marine species. As the sea approached its modern level, the pace of change slowed. The dramatic daily advances of the shoreline became less noticeable. The system settled into a new equilibrium. But the memory of that rapid rise remained, not in any conscious sense, but in the physical structure of the region. The shape of the seafloor, the distribution of sediments, the alignment of coastlines. All of these carry the imprint of a time when water moved faster and farther than it usually does. It's interesting to compare that ancient moment to the changes we observe in the world today. Modern sea level rise driven by climate change is a topic of concern precisely because it affects coastlines, ecosystems, and human settlements. In most places, that rise is measured in millimeters per year, not meters per day. And yet, even those small changes can have significant impacts over time. The Zanclean Flood provides a kind of extreme reference point. It shows how dramatically a sea can change when the conditions are right, when a barrier falls and when gravity is given a path. There's a humbling quality to that perspective. It reminds us that the planet operates on scales of power and time that far exceed our own. As the Mediterranean reached its new level and the rising slowed, the world entered a period of relative calm. Not stillness exactly, but a different kind of motion. The steady rhythms of tides, currents, and seasonal weather patterns replaced the dramatic climb of the flood. The sea became part of the everyday structure of the region, shaping cultures, climates, and ecosystems in ways that would continue to unfold into the present. But beneath that calm surface, the story of the fastest rising sea in Earth's memory remained written into the rocks and sediments below. It's a story of thresholds crossed, of potential released, of a basin transformed in a way that, from the perspective of deep time, was astonishingly swift. As you sit with that image, you might notice how your own sense of speed and slowness shifts. A few meters per day can feel both fast and slow, depending on what you're comparing it to. Compared to a human walking, it's nothing. Compared to the movement of continents, it's a blur. The Earth in this moment did something rare. It changed quickly, and from that quick change emerged a sea that would become a defining feature of a region, a source of climate, culture, and connection for millions of years to come. As the Mediterranean settled into its new shape, something else began to take form above its surface. The sea was no longer just a basin filled with water. It became a moving, breathing presence in the atmosphere, a wide expanse that absorbed heat by day, released it by night, and quietly reshaped the behaviour of the air that passed over it. This is where the story lifts its gaze from the surface of the water to the space above it, where invisible currents began to draw new patterns across the sky. A newborn sea does not behave like a long-established one. Its temperatures, its salinity, and its internal circulation were still finding balance. The water entering from the Atlantic mixed with the warmer, saltier water that formed within the basin. Layers developed, currents shifted, and the surface responded to sunlight in ways that were still evolving. All of this mattered to the air above. Warm water releases heat into the atmosphere. Cool water absorbs it. When a wide body of water sits next to land, especially land that can heat up and cool down quickly, it creates contrasts. Those contrasts drive motion. During the day, sunlight warmed the land around the Mediterranean faster than it warmed the sea. Warm air over the land rose, becoming lighter and drifting upward. Cooler, denser air over the water moved in to replace it. A breeze formed, flowing from sea to land. At night, the pattern reversed. The land cooled quickly, the sea held onto its warmth, and air began to move back toward the water. These daily rhythms of wind are familiar in many coastal regions today, but in the early days of the Mediterranean's return, they would have been part of a larger, more dynamic system. The presence of a wide, warm surface of water changed how pressure systems developed across the region. Warm air rising over the sea could lead to areas of lower pressure, drawing in air from surrounding lands. As that air moved, it picked up moisture, heat, and energy. Storms are, in many ways, the atmosphere's way of redistributing energy. When warm, moist air rises and meets cooler air above, it can condense into clouds, releasing latent heat and fueling further motion. The newborn Mediterranean became a new source of that warm, moist air. Clouds would have formed more frequently over the sea, especially during certain seasons. Some of these clouds would drift inland, bringing rain to areas that had been drier during the basin's empty phase. Others would grow into larger systems, driven by broader patterns of atmospheric circulation. The result was a region where weather began to take on new complexity. Winds that once flowed relatively uninterrupted across dry land now encountered a wide, open surface of water. The friction, temperature differences, and moisture availability altered their behaviour. Some winds strengthened as they moved over the warm sea. Others shifted direction as pressure patterns changed. If you were to stand on a high point overlooking the Mediterranean during this period, you might have noticed how often the sky seemed to be in motion. Clouds building, stretching, breaking apart. Sunlight filtering through in shifting patterns. The air itself feeling restless. This restlessness had a direct impact on the sea below. Wind is one of the main drivers of waves. As it blows across the surface of water, it transfers energy, creating ripples that can grow into larger waves the longer the wind blows and the farther it travels across open water. In the newly formed Mediterranean, winds could sweep across long stretches of uninterrupted surface, especially in the larger central parts of the basin. This allowed waves to build and travel, shaping the coastlines as they reached the shore. Rocky areas resisted, breaking the waves into spray and foam. Softer, sediment-rich areas gave way more easily, allowing beaches and sandbars to form. Over time, this constant interaction between wind, water and land refined the shape of the coast. But the influence of storms went beyond shaping shorelines. Strong weather systems can drive surface currents in the sea, pushing water in particular directions. This movement can cause deeper water to rise in some areas, bringing nutrients to the surface. In other areas, surface water can be pushed away, allowing cooler, deeper water to take its place. These processes, known as upwelling and downwelling, play a major role in marine ecosystems. They affect where plankton thrives, which in turn influences where fish and larger animals can find food. As the Mediterranean developed its own patterns of wind and storm activity, it also began to develop these internal biological rhythms. The timing and intensity of storms likely varied with the seasons, influenced by changes in sunlight, temperature, and large-scale atmospheric circulation. In some periods, the sea might have been relatively calm, with gentle breezes and scattered clouds. In others, powerful systems could have swept across the basin, bringing heavy rain, strong winds, and rough waters. For the surrounding land, these storms represented another shift in the way water moved through the environment. Rainfall patterns became more closely tied to the presence of the sea. Coastal regions might have experienced more frequent precipitation, while inland areas felt the effects of moisture carried by prevailing winds. Rivers responded accordingly. Increased rainfall could lead to stronger flows, especially during stormy seasons. These rivers carried sediment from hills and plains back into the sea, continuing the slow process of reshaping both land and sea floor. In this way, the newborn Mediterranean became part of a feedback loop. The sea influenced the air influenced the rain influenced the rivers influenced the sea. This loop, once established, would persist for millions of years, even as climates shifted and continents continued to move. It's interesting to think about how different this was from the world that existed just before the flood. The dry basin would have had its own weather patterns, but without a large body of water to moderate temperatures and provide a steady source of moisture, those patterns would have been simpler in some ways and more extreme in others. The return of the sea introduced a kind of atmospheric richness. More clouds, more varied winds, more complex interactions between land and sky. For any life in the region, this change would have been deeply influential. Plants along the coasts and in nearby highlands would have benefited from more consistent moisture in some areas. Wetlands could form in low-lying regions where water collected after storms. These wetlands, in turn, would become habitats for a variety of animals. Birds in particular would have found new opportunities. Coastal and marine environments often provide rich feeding grounds. Storm systems can also influence migration patterns, creating wind corridors that birds can use to travel long distances. Over time, the Mediterranean would become an important crossroads for migratory species, a role it still plays today. But in the early days of its return, everything was still adjusting. The chemistry of the water was changing as Atlantic water mixed with the basin's own evolving composition. Salinity levels fluctuated. Temperature gradients shifted. These factors influenced how much water evaporated and how quickly clouds formed. In some periods, the sea might have been warmer, releasing more moisture into the air and fueling stronger storms. In others, cooler conditions might have led to calmer weather. The exact details of these early patterns are difficult to reconstruct, but the general principle remains. A large body of water changes the atmosphere above it in fundamental ways. You can observe this in the modern world. Regions near oceans and large lakes often have milder climates than those farther inland. Summers are cooler, winters are warmer, and rainfall patterns are influenced by the proximity of water. The Mediterranean's return would have begun this process for the surrounding lands. From the perspective of deep time, this was the moment when the region's familiar climate character began to take shape. The hot, dry summers and mild, wetter winters that define much of the modern Mediterranean climate are tied to the presence of the sea and the way it interacts with large-scale atmospheric systems. Those systems, in turn, are influenced by the broader circulation of the planet's atmosphere, including the movement of air between the equator and the poles. The Mediterranean sits in a zone where different air masses can meet. Warm, dry air from subtropical regions can collide with cooler, moister air from higher latitudes. This meeting point is often where storms form. With the sea in place, this interaction gained a new dimension. The moisture and heat from the water added energy to these systems, sometimes intensifying them. This doesn't mean the region became a constant storm zone. Instead, it gained a wider range of possible weather conditions, from calm, clear days to periods of dramatic wind and rain. If you imagine watching the sky over the Mediterranean during this period, you might see long stretches of blue punctuated by sudden changes, a line of clouds forming on the horizon, the wind picking up, the air growing cooler and heavier as a storm approached. These moments of transition would have been part of the sea's ongoing conversation with the sky. The winds themselves became a defining feature of the region. Certain wind patterns, shaped by the surrounding mountains and the shape of the coastline, could funnel air through narrow passages, increasing its speed. Valleys and straits acted like natural wind tunnels, guiding and accelerating the flow. These winds influenced navigation for any creatures moving across the sea, including birds and, much later, humans. They also affected how waves formed and how surface currents moved. In some areas, persistent winds could drive water away from the coast, causing deeper water to rise. This upwelling brings nutrients to the surface, supporting plankton blooms that form the base of the marine food web. So a strong wind, while it might seem like a surface phenomenon, can have effects that reach all the way down to the sea's biological foundations. The newborn Mediterranean, then, was not just a body of water, it was a system in the process of becoming. Its physical shape, its internal currents, its interaction with the air and its influence on life were all evolving together. There's something quietly fascinating about that stage of development. A sea learning how to be a sea. Over time, patterns would become more established. Certain winds would become seasonal. Storm tracks would tend to follow similar routes year after year. Marine ecosystems would adapt to the regular rhythms of temperature and nutrient flow. But in these early days, there was likely more variability. More experimentation, in a sense, as the system explored different states before settling into a relatively stable configuration. From a human perspective, variability can feel unsettling. We tend to prefer predictability in the weather, in the seasons, in the rhythms of daily life. But from the perspective of the planet, variability is part of the process of finding balance. The Mediterranean's early atmosphere would have been a place of such exploration. As the sea continued to influence the sky, it also began to influence the broader region's relationship with water. Rainfall patterns that changed because of the sea's presence would have affected where rivers flowed and how much water they carried. This, in turn, influenced where sediments were deposited, shaping plains and deltas that would become fertile areas for plant growth. These fertile regions, long after the flood, would become important for human societies. The presence of a stable sea and predictable climate patterns would support agriculture, trade, and settlement. So in a very long, indirect way, the storms and winds of the newborn Mediterranean helped set the stage for future civilizations. But at this point in the story, there were no cities, no ships, no maps, just water, air, land, and life adjusting to a new reality. If you step back and think about it, the image is both simple and complex. A sea beneath a sky, winds moving, clouds forming, rain falling, rivers flowing. It's a cycle we recognize, but the scale and context here give it a different weight. This cycle was newly formed in this region. It had not existed in this way for a very long time. The atmosphere, in a sense, was rediscovering how to move around a sea that had been absent. As the years and centuries passed, the drama of the flood faded into the background. The cascade at the narrow gate softened into a steady exchange. The rising shoreline stabilized. the winds and storms became the main visible expressions of the sea's energy. These expressions were not as visually striking as a waterfall taller than mountains, but they were just as important in shaping the world that followed. The land continued to change under the influence of rain and wind. The sea continued to circulate, mix and support life. The sky continued to carry water from one place to another. Together, they formed a system that would endure, with variations, for millions of years. As you sit with this idea, you might notice how often we separate things in our thinking. Land here, water there, air above. But in reality, they are deeply connected. The Zanclean Flood is a powerful example of that connection. A change in a narrow strip of land led to a change in a sea. A change in a sea led to changes in the sky. Changes in the sky led to changes in the land far beyond the original event. The story, in other words, spread outward. And as it spread, it began to touch more than just the physical environment. It began to shape the conditions for life, for movement, for future histories that would unfold in ways no one could have predicted at the time. As the Mediterranean's waters continued to settle into their new place beneath the sky, the most immediate and intimate effects of this transformation were felt not in rock layers or wind patterns, but in the lives of the creatures that lived along the shifting boundary between land and sea. This was where the change became personal, not in a human sense, but in the quiet, instinctive language of movement, shelter, hunger, and survival. At the edge of the rising water, the world was no longer stable in the way it had been for thousands of years. The line between dry ground and open water was not fixed. It moved, sometimes slowly, sometimes with a pace that would have been noticeable even over a short span of time. For the plants rooted in the soil and the animals that depended on them, this moving line meant one thing above all else: adjust or move. Imagine a stretch of low-lying land near the basin's former centre. For generations of life it might have been a place of rivers, shallow lakes and patches of vegetation. Insects buzzed over pools of fresh water. Small mammals moved through reeds and grasses. Larger animals passed through on their way between higher ground and water sources. As the Mediterranean rose, those freshwater pools began to taste different. A hint of salt crept in. At first it might have been subtle, barely noticeable, but over time the change became clear. Some plants yellowed and withered, unable to tolerate the new conditions. Others, more tolerant of brackish water, held on. The insects followed the plants, the birds followed the insects, the small mammals followed the birds or the shelter the vegetation provided. A chain reaction unfolded, driven by a simple physical change in the water. This is often how environmental transformations ripple through ecosystems. They don't usually arrive as a single dramatic blow. They arrive as a shift in something basic: salinity, temperature, water level, and from there, everything else responds. Along the newly forming coastlines, life found opportunity as well as challenge. Marine organisms arriving from the Atlantic brought with them a wave of microscopic life. Plankton, the tiny drifting organisms that form the base of most ocean food webs, began to populate the new sea. Some species would have thrived in the changing conditions. Others would have struggled as salinity and temperature fluctuated. These tiny organisms may be small, but their impact is immense. Where plankton grows, larger life can follow. Small fish feed on plankton, bigger fish feed on smaller fish. Birds and marine mammals feed on fish. A whole web of life begins to take shape, anchored by creatures too small to see with the naked eye. In the early Mediterranean, this web would have been in flux. Conditions were still stabilising. Currents were still finding their patterns. Nutrients were being redistributed by the mixing of water and the input of sediment from rivers. In some areas, plankton blooms might have been intense, fueled by nutrients stirred up from the seafloor or carried in by rivers. These blooms could create rich feeding grounds, drawing in fish and the creatures that preyed on them. In other areas, conditions might have been harsher, with fewer nutrients or less stable water chemistry. Life there would have been sparser, This patchwork of abundance and scarcity would have shaped how marine species spread through the basin. Fish arriving from the Atlantic would have explored new habitats, following currents and food sources. Some would have found suitable environments and established populations. Others would have retreated or perished if conditions didn't suit them. Over time, this process would lead to a distinct Mediterranean marine community, related to but not identical to the Atlantic's, a blend shaped by the basin's unique conditions. But the story of life at the edge of this changing world wasn't limited to the water. On land, animals faced a landscape that was literally shrinking in some places. Low-lying areas disappeared beneath the rising sea, valleys became inlets, plains became shallow bays. For creatures that lived close to the water, this meant a gradual retreat upslope. Each generation might have found the shoreline a little higher than the last. Habitat shifted accordingly. Some species are well suited to this kind of change. Birds, for example, can simply move. If a nesting area becomes unsuitable, they can search for another. Many mammals can travel long distances in search of new territory. Plants, however, are tied to the soil. Their movement depends on the spread of seeds. As water covered their former ground, their seeds would need to find new places to take root, carried by wind, animals, or flowing water. This process of relocation can be slow and uncertain. Some plant species might have failed to keep up with the pace of change, disappearing from certain areas entirely. Others, more adaptable or with more effective ways of spreading their seeds, would have followed the retreating edge of dry land. Over time, this would have reshaped the vegetation patterns around the Mediterranean. Coastal plant communities, adapted to salt spray and shifting soils, would have expanded. Inland communities would have adjusted to new rainfall patterns, influenced by the sea's presence. Insects, always quick to respond to changes in plant life, would have followed suit. Pollinators would track flowering plants. Herbivores would follow their food sources. Predators would follow the herbivores. The edge of the sea became a moving, ecological frontier. There's a certain quiet drama in that idea. Not the kind of drama marked by sudden catastrophe, but the kind marked by countless small decisions made by living things. Where to feed, where to shelter, where to raise young. Each of those decisions, repeated across thousands of species and millions of individuals, helped shape the living character of the region. Freshwater environments were among the most affected. Rivers that once flowed into a dry basin now met a rising sea. Their mouths became estuaries, places where freshwater and saltwater mix. Estuaries are often among the most productive ecosystems on Earth, rich in nutrients and shelter. In the newly forming Mediterranean, these zones would have been dynamic and shifting. The balance between river flow and sea level would change as the flood progressed and as rainfall patterns adjusted. Some species thrive in these in-between environments. Certain fish, crustaceans, and plants are adapted to tolerate a range of salinity levels. These organisms could take advantage of the new habitats, spreading into areas that were previously unsuitable. Other species, more sensitive to salt, would have been pushed farther upstream, retreating into purely freshwater zones. This created a kind of ecological sorting, with species finding their place along a gradient from land to sea. For larger animals, the changing world presented both obstacles and opportunities. Imagine a herd of land mammals that had, for generations, followed a particular route across a low-lying plain to reach water or grazing grounds. As the sea advanced, that route might have become submerged. The herd would need to find a new path, perhaps through higher ground or around the edge of a newly formed bay. These changes could alter migration patterns, bringing animals into contact with new environments and other species they hadn't encountered before. In some cases, this kind of movement can lead to competition for resources. In others, it can lead to new forms of coexistence or even new evolutionary paths. Over long periods, geographic changes like the formation of seas and straits can isolate populations. When groups of the same species become separated by water or difficult terrain, they may begin to evolve independently, adapting to their specific environments. the Mediterranean's return, by reshaping coastlines and creating new bodies of water, could have contributed to this process in subtle ways. Islands formed, peninsulas became separated, valleys turned into channels. Each of these features had the potential to divide populations and set them on slightly different evolutionary journeys. In the water, similar processes were at work. As marine species spread into the basin, they encountered a semi-enclosed environment. Unlike the open Atlantic, the Mediterranean is connected to the wider ocean by a narrow strait. This limits the exchange of water and organisms. Over time, this can lead to the development of unique species or unique variations of species found elsewhere. The early stages of this process would have begun soon after the flood. Fish, invertebrates, and microscopic life entering the basin would have faced conditions that differed from those in the open ocean. Warmer temperatures, higher salinity, and different nutrient patterns would all act as selective pressures. Some species would adapt, others would not. The result over millions of years would be a Mediterranean ecosystem with its own distinct character. But in the immediate aftermath of the flood, the focus was less on long-term evolution and more on immediate survival. For creatures at the edge of this changing world, every day brought new conditions. A patch of ground that was safe one season might be underwater the next. A familiar feeding area might become too salty to support the plants or animals that once lived there. A river might change its course as rising water backed it up or altered its flow. There's something quietly profound about that level of uncertainty. It's easy to imagine it as chaotic or stressful, but it's also the state in which life has always existed in one form or another. Environments change. Life responds. In many ways, the flood created a moving laboratory of adaptation. Some species likely took advantage of the new conditions. Coastal environments can be rich in resources. The mixing of land-derived nutrients and marine systems can create zones of high productivity. Scavengers, for example, might have found abundant food along the shifting shoreline. Predators might have followed concentrations of prey drawn to these productive areas. Birds that fed on fish, insects, or plants near water would have found new feeding grounds as the sea expanded. The rising water also created new physical structures. Rocky outcrops became islands. These islands could serve as nesting sites for birds, refuges for certain plants, or stepping stones for animals moving along the coast. Over time, these features would be reshaped by waves and erosion, but in the early days they added to the complexity of the landscape. The interplay between land and water is often where biodiversity flourishes. Edges, in ecological terms, tend to support a wide range of species because they combine elements of two different environments. The Mediterranean's return created an enormous new edge, a coastline stretching for thousands of kilometres, with countless variations in shape, slope and exposure. Each section of that coastline offered a slightly different set of conditions. Sheltered bays, exposed cliffs, sandy shores, rocky coves, shallow lagoons. Life found its way into each of these niches. It's also worth considering the role of time in all of this. From the perspective of an individual animal or plant, the flood might have seemed like a slow, ongoing change, something that unfolded over many generations. There was no single moment when the world suddenly became different. Instead, it was a gradual shift, marked by small adjustments and relocations. From the perspective of the planet, however, this was a rapid event, a short interval that reshaped a region. This difference in perspective highlights something interesting about how change is experienced. Scale matters. What feels slow and manageable at one level can be fast and dramatic at another. As the Mediterranean stabilized, the pace of change slowed. The shoreline's movement became less noticeable. The salinity levels in estuaries settled into more predictable patterns. Rainfall and river flows found new averages. Life in turn began to settle into more stable relationships with the environment. But the memory of that moving edge remained in the genetic and ecological makeup of the region. Species that survived and thrived during this period carried forward traits that helped them cope with change. tolerance for varying salinity, flexibility in habitat use, the ability to disperse effectively. These traits would continue to be useful in a region that, even after the flood, would experience ongoing environmental variation driven by climate shifts, tectonic movements, and human influence much later. There's a certain continuity in that idea. The flood didn't just create a sea, it helped shape the kinds of life that would live around it. As you picture this world of shifting boundaries and adapting creatures, you might notice how different it feels from the earlier, more physical parts of the story. We've moved from rock and water and gravity into something more delicate: behaviour, movement, survival. It's a reminder that Earth's history is not just a history of landscapes, but a history of lives. Every change in the planet's shape creates a cascade of changes in the living world, and every living thing, in its own small way, becomes part of the planet's ongoing story. The edge of the changing Mediterranean was one of those places where this connection was especially visible. On one side, the deepening sea, with its swirling currents and growing marine communities. On the other, the land, with its rivers, plants and animals adjusting to new patterns of rain and coastline. Between them, a narrow shifting zone where water met soil, salt met fresh, and old paths gave way to new ones. If you let your imagination rest there for a moment, you might picture a quiet scene. A bird standing at the edge of a shallow inlet, watching small fish move through the water. A plant rooted just above the tide line, its leaves catching spray from the waves. An animal path winding along a hillside that now overlooks a bay instead of a valley. None of these scenes would have announced themselves as part of a great geological event. They would have felt ordinary to the creatures living them, and yet, from a distance in time, they form part of one of the most dramatic transformations in the region's history. The flood's influence, in this sense, was not just written in stone and sediment. It was written in movement, in behaviour, in the quiet persistence of life finding a way in a world that would not stay still. As the Mediterranean continued to mature as a sea, these living stories layered on top of one another, generation after generation, creating the complex web of ecosystems that would define the region for millions of years. Beneath the calm surface of the modern Mediterranean, far below the reach of sunlight and waves, the planet keeps a quiet archive. It isn't written in ink or carved into monuments. It's layered into stone, pressed into sediment, and sealed away in darkness where time moves in slow, patient steps. This is where the story of the Great Flood continues to speak, not through sound or motion, but through texture, chemistry, and shape. If you could somehow drift downward through the water, past schools of fish and shifting currents, past the faint glow of the upper layers into the dim blue and then into near blackness, you would eventually reach a landscape that feels both familiar and strange. The seafloor is not a smooth, featureless plain. It's a terrain with ridges, channels, slopes and valleys, shaped by forces that acted both when this place was dry land and when it became a sea again. This is one of the most remarkable aspects of the Mediterranean's history. Its floor carries the fingerprints of two very different worlds layered on top of each other. Long before the flood, when the basin lay exposed beneath the sun, rivers carved deep paths into the land. Wind moved fine grains of sediment across open flats. Salt settled in thick, crystalline sheets where water evaporated. All of that left behind a pattern, a kind of topography written by air and gravity rather than by waves and currents. When the water returned, it didn't erase that pattern. It covered it. The rising sea filled valleys, drowned ridges, and smoothed some features while leaving others surprisingly intact. In some places, the underwater landscape still resembles a river valley, complete with branching channels and steep sides, even though no river has flowed there for millions of years. Modern technology allows scientists to see this hidden world in a way that would have been unimaginable not long ago. Using sonar, they send sound waves down through the water and listen for the echoes that bounce back from the seafloor. By measuring how long those echoes take to return and how they change, they can build detailed maps of the underwater terrain. These maps reveal a seafloor that tells a layered story. In certain areas, especially near the edges of the basin, long winding channels can be traced beneath the water. These channels often align with the courses of ancient rivers that once flowed across the dry basin floor. Their shapes are too large and too distinct to be explained by modern ocean currents alone. They are, in a sense, ghost rivers. Further out, the seafloor sometimes drops away in steps or terraces. These can mark former shorelines, places where the rising sea paused for a time or where changes in the rate of inflow created temporary levels. Each terrace represents a moment when the water's advance slowed, even if only briefly, leaving behind a subtle line in the shape of the land. But perhaps the most striking geological record of this period lies not just in the shape of the seafloor, but in what lies beneath it. Below layers of more recent marine sediment, scientists have found enormous deposits of salt, sometimes hundreds of meters thick. These are the remnants of the time when the Mediterranean basin was largely cut off from the Atlantic and water evaporated faster than it could be replaced. When seawater evaporates, it leaves its dissolved minerals behind. Salt is one of the most abundant of these. Over long periods, repeated cycles of inflow and evaporation can build up thick layers of crystalline material on the basin floor. These salt layers, known as evaporites, are like a geological signature. They tell of heat, dryness, and a sea that shrank or disappeared. Above them, in many places, lie different kinds of sediments. Finer materials deposited by calmer waters, layers that include the remains of marine organisms, tiny shells, and chemical markers that indicate more stable, fully marine conditions. The boundary between these two types of layers is a kind of turning point in the rock record. Below it, a world of evaporation and exposure. Above it, a world of open water and circulation. By studying this boundary, scientists can estimate when the flood occurred and how quickly conditions changed. The sharpness of the transition in some locations suggests that the shift from dry to marine conditions was relatively rapid. This doesn't mean every part of the basin experienced the change at the exact same moment. The shape of the land would have influenced how quickly water arrived in different areas. But on the scale of millions of years, the overall transformation stands out as sudden. The chemistry of these layers adds another dimension to the story. Seawater carries a distinctive mix of elements and isotopes. When marine organisms build shells, they incorporate some of these elements into their structures. When those organisms die, their shells settle to the seafloor and become part of the sediment. By analysing the composition of these remains, scientists can learn about the temperature, salinity, and chemistry of the water at the time they were formed. In the layers just above the salt deposits, the chemical signatures often show a rapid return to open ocean conditions. This supports the idea of a strong, sustained inflow of Atlantic water, rather than a slow, gradual trickle. There are also physical clues embedded in the rocks themselves. In some areas, sediment shows signs of being deposited by fast-moving water. These can include graded layers, where heavier particles settle out first and finer ones later, indicating a flow that slowed over time. Such patterns are common in river floods and underwater landslides. Finding them in deep parts of the Mediterranean suggests that powerful currents and sediment-laden flows were active during the basin's refill. The shape of the seafloor near the Strait of Gibraltar provides another piece of evidence. Here, sonar mapping has revealed large eroded features that resemble channels carved by strong flows of water. These channels are much larger than what modern currents would be expected to create. Their size and form point to a period of much more intense movement, consistent with a massive influx of water. Together, these clues form a kind of puzzle. No single feature tells the whole story. A channel here, a salt layer there, a chemical signature in a tiny fossil. But when you put them together, they begin to outline a sequence of events that matches the idea of a largely dry basin, followed by a rapid, powerful refill. It's a slow, careful process to piece this together. Scientists drill cores from the seafloor, sometimes kilometres beneath the surface. They analyse samples grain by grain, layer by layer. They compare findings from different parts of the basin, looking for patterns that repeat or change. This work doesn't happen quickly. It unfolds over years, sometimes decades, as new data adds detail and occasionally challenges earlier ideas. What makes this especially fascinating is how indirect the evidence is. No one recorded the flood. No instrument measured the rising water. Everything we know comes from what was left behind. Stone, in this sense, becomes a kind of memory. Not a memory in the way we think of it, with images and stories, but a physical record of processes that took place. Pressure, heat, chemistry and motion all leave marks, and those marks can be read if you know how to look. There's something quietly profound about that idea. The planet doesn't forget. It doesn't archive in the way we do, but it carries forward the results of what has happened. Even in places where the seafloor is now covered by thick layers of younger sediment, the older layers remain below, pressed and preserved. They may be altered by heat and pressure over time, but their basic story remains. In some parts of the Mediterranean, these salt layers have even become important for human reasons. Salt is less dense than many other types of rock, so it can flow slowly under pressure, forming structures known as salt domes. These can trap oil and gas, making them significant in the context of energy resources. So, a geological event from millions of years ago continues to influence human activity today, in a way that's both practical and unexpected. The seafloor story isn't limited to what lies beneath the sediment. The shape of the basin itself reflects the history of the flood and what came before it. The deepest parts of the Mediterranean are found in regions that were already low before the refill. These areas filled first and became the core of the new sea. Shallower regions near the edges reflect areas that were higher ground, flooded later as the water rose. This pattern influences modern oceanography. The depth and shape of the basin affect how water circulates, where currents flow, and how heat is distributed. In some places, deep basins are separated by underwater ridges, creating compartments within the sea. Water exchange between these compartments can be limited, leading to differences in temperature, salinity, and biological activity. These features trace back in part to the pre-flood landscape. Ridges that were once hills or high ground now sit beneath the water, guiding the movement of currents above them. There's a kind of continuity in that. The land that once shaped rivers and valleys continues to shape currents and ecosystems, even after being submerged. If you imagine tracing a line across the seafloor, following one of these submerged ridges, you're essentially following a piece of ancient topography. A hill that once stood under the sun now stands under hundreds or thousands of meters of water. The idea can feel almost dreamlike, but it's grounded in physical reality. This layered nature of the Mediterranean's history makes it a particularly rich place for geologists. It's a region where dramatic change has left clear, interpretable marks. But interpreting those marks is not always straightforward. There are debates about the exact timing and duration of the flood. Different models propose different rates of inflow and different sequences of events. Some suggest a very rapid refill, on the order of months to a few years. Others allow for a more prolonged process, perhaps with pulses of faster flow followed by slower periods. The rock record can sometimes support multiple interpretations. A particular sediment layer might be explained by a single, intense event or by a series of smaller ones. Chemical signatures can be influenced by more than one factor. This uncertainty is not a flaw in the science. It's a reflection of how complex natural systems are and how indirect our window into the past must be. What remains consistent across these different models is the overall picture. There was a time of extreme dryness and evaporation, followed by a return of marine conditions that appears, in geological terms, to have been relatively rapid. The seafloor, in its shapes and layers, supports that narrative. There's also a broader context to consider. The Mediterranean does not exist in isolation. It's part of a global ocean system. changes in its connection to the Atlantic would have had effects beyond the basin itself. During the dry period, the reduced exchange of water could have influenced global ocean circulation patterns. When the connection reopened, the sudden influx of water and the re-establishment of flow would have altered those patterns again. Some scientists have explored the idea that this event might have had subtle effects on climate beyond the immediate region, though this is an area of ongoing research. Even if the global impact was limited, the regional effects were profound. The seafloor's record allows scientists to connect the Mediterranean story to larger patterns of tectonic movement, climate change, and ocean circulation. It becomes part of a much bigger picture of how the planet evolves. From a more reflective perspective, there's something almost comforting about the way stone holds on to these stories. We live in a world where information is often fleeting. Digital records can be lost. Memories fade. But the planet's memory is slow and deep. It takes immense forces to erase or overwrite what has been written into rock. The salt layers beneath the Mediterranean have survived millions of years. They've endured pressure, heat, and the weight of water and sediment above them. And still they remain, quietly telling of a time when a sea disappeared and then returned. If you could hold a piece of that rock in your hand, you would be holding a fragment of that story. Not in a symbolic sense, but in a literal one. The crystals within it formed under a specific set of conditions, in a specific moment of Earth's history. That's one of the quiet wonders of geology. It turns the planet itself into a kind of book, one that can be read with patience and care. It might shift the way you think about the ground beneath your feet, or the water you might see on a map. These are not just static features. They are the surface expressions of a long, layered history. The Mediterranean surface today is calm in many places. Ships move across it. Sunlight glints off its waves. From above, it looks like a stable, enduring part of the world. But beneath that surface lies a memory of motion, of absence and return, of water that once fell, poured and spread with remarkable speed. The traces left in stone are not loud. They don't announce themselves, but they are persistent. They wait, quietly, for someone to look, to measure, to ask questions. And when those questions are asked, the answers that emerge connect a modern sea to an ancient event, a calm surface to a dramatic past. Imagine for a moment a pair of human eyes placed gently into a world that existed millions of years before the first true humans ever walked the earth. Not as a visitor with tools and maps, not as a scientist with instruments, but simply as a quiet observer, standing on a rise of land and looking out over a planet in the middle of changing itself. From that vantage point, the first thing you would likely notice is how wide everything feels. The sky would stretch without interruption, a broad dome of light and moving clouds. The land would roll outward in long, uneven slopes, broken by ridges and valleys that guide the eye toward a horizon that seems to curve slightly with the shape of the world. And somewhere in the distance, depending on when you arrived in this imagined moment, you might see something that looks like a shimmer, a faint reflective line that wasn't there before. That line would be water. If you had arrived early in the flood's progress, the Mediterranean would still be a growing presence rather than a fully formed sea. From higher ground, you might look down into what was once a vast open basin and see a patchwork of deep pools, narrow channels, and broad, spreading sheets of water creeping across the land. The air would feel different from what you'd expect in a dry, sun-baked region. There would be moisture in it, a faint coolness that softens the heat of the day. The breeze might carry a subtle, salty tang, hinting at the presence of a large body of water nearby. And there would be sound. Not just the quiet of wind moving through grasses or the calls of distant animals, but a low, continuous note carried from far to the west. The deep, steady roar of the great cascade at the narrow gate, travelling across the landscape like a distant storm that never quite moves away. As you walked closer to the edge of the rising water, The details of the world would sharpen. The ground underfoot might be uneven, shaped by old river channels that once carried fresh water toward the basin's centre. In some places, the soil would be damp, darkened by the recent arrival of water. In others, it would still be pale and dusty, waiting its turn to be claimed by the sea. Small streams might run toward the growing shoreline, their flow now slowed or even reversed in the lowest areas as the sea pressed back against them. Where fresh water met salt water, the water's surface could show subtle changes in colour and texture, a visual blending of two different worlds. Plant life near this boundary would tell its own story. Some plants would be green and thriving, rooted in ground that still received fresh water and consistent rainfall. Others, closer to the advancing edge, might show signs of stress. Leaves yellowing, stems drooping, salt in the soil beginning to interfere with their ability to draw in water. Birds might gather along these shifting margins, drawn by the abundance of life. Insects hovering over pools, small fish venturing into brackish inlets. The edge between land and sea would be alive with motion, a place of constant activity. If you lingered there long enough, you might notice something that feels almost unsettling. The sense that the world is not staying put. A rock that sat high and dry one day might be surrounded by shallow water a short time later. A path you walked across might become muddy, then submerged. The landmarks you used to orient yourself would slowly change, not through sudden destruction, but through steady, persistent movement. Looking out across the water itself, the surface would not always be calm. Winds sweeping across the growing sea would raise waves that travel toward the shore, breaking against newly formed coastlines. In sheltered areas, the water might be smooth and reflective, mirroring the sky above. In more exposed regions, it could be choppy, darkened by clouds and stirred by passing storms. Farther from shore, the sea would deepen, shifting from lighter, sediment-filled colours near the edges to darker blues and greens where the water grew clearer and deeper. If you had the ability to travel, to move across this changing landscape, the contrasts would become even more apparent. Climb higher, and you would see the growing sea as a broad, spreading presence, filling lowlands and wrapping around hills. Move closer to the narrow gate in the west, and the character of the world would change again. There, the air would be thick with mist. The ground would be damp, even slick in places. The sound would be overwhelming. The cascade itself, if you could approach it safely, would dominate everything. A wide front of water pouring downward, breaking into spray and foam, throwing droplets into the air that catch the light and fall back to the ground like a constant fine rain. The wind near the falling water would be unpredictable, driven by the movement of air displaced by the flow. Gusts could come from unexpected directions, carrying the cool breath of the Atlantic or the warmer air rising from the basin below. The ground near the edge would feel alive underfoot, not in a literal sense, but in the way it responds to the forces acting on it. Vibrations from the falling water might be faintly perceptible. The soil could shift as erosion undermines slopes and small collapses occur. It would not be a place to linger for long. Step away from that dramatic zone, though, and the world would return to a quieter, more expansive feeling. On the higher ground around the basin, you might find broad plains, rolling hills and valleys that still look much as they did before the flood, at least at first glance. But even here, signs of change would be present. Clouds might appear more frequently. Rainfall could come in patterns that feel new or unfamiliar. Rivers might swell more often, carrying more water and more sediment than they once did. These changes would shape the land in subtle ways, banks eroding, new channels forming, wetlands appearing in low-lying areas where water collects after storms. If you were there long enough to experience the seasons, you might notice how the rhythm of the year begins to shift. Periods of rain and dryness would take on a new balance, influenced by the presence of the sea. The air might feel cooler in summer near the coast, warmer in winter than it did when the basin was dry. These are the kinds of changes that, to a human observer, might feel like a gradual adjustment rather than a dramatic transformation. But when you step back and look at them together, they form a clear picture of a world finding a new equilibrium. The sky itself would be part of the spectacle. Storms would roll in from the west or form over the sea, the clouds towering and darkening as they gather moisture and energy. Lightning might flash within them, briefly illuminating the surface of the water and the surrounding land. After the storm passes, the air would feel fresh and cool. The ground would glisten. Small streams might run where there were none before, carrying water back toward the growing sea. These moments of contrast between calm and turbulence, light and shadow, would become a defining feature of the region. If you were to move along the coastline, following the edge of the rising Mediterranean, you would encounter a wide range of environments. In some places, steep cliffs would drop straight into deep water, waves breaking against rock and sending spray into the air. In others, gentle slopes would lead down to shallow bays, where water lapped quietly against sand and mud. You might walk past areas where the sea has only recently arrived, where plant debris and soil still float at the surface, and then move into regions where the water is clearer, more settled, and already supporting marine life. Fish might dart through the shallows, crustaceans might scuttle along the bottom, the surface might ripple as something breaks the water and disappears again. The sense of newness would be strong. This sea, in a way, would feel young, not in age, but in character. It would be in the process of establishing itself, of building the relationships between currents, winds, and life that would eventually define it. If you stood on a high ridge at sunset, the view could be striking. The sun would lower toward the horizon, casting long bands of light across the water. The surface of the sea might glow with shades of gold and orange, while the land behind you fades into shadow. From that vantage point, you could see how far the water has spread, how valleys that once guided rivers now hold narrow arms of the sea, how hills that once rose from dry ground now rise from water. It would be a scene that feels both peaceful and full of motion at the same time. The idea of being there, even in imagination, brings up an interesting contrast. On one hand, much of what you would see would look familiar. Water, sky, land, clouds, animals, plants, the basic elements of a world we recognise. On the other hand, the pace of change would be unfamiliar. The sense that the environment is not fixed, that the map is being redrawn as you watch. For a human mind, that could be both fascinating and unsettling. We tend to build our lives around stable features, a coastline, a river, a mountain. We assume they will be there tomorrow and next year, and often for generations. In this imagined world, those assumptions would be harder to hold. If you return to the same place after a few years, the view might be noticeably different. The waterline higher, the vegetation changed, the path you once walked now underwater. And yet, life would go on. Birds would still fly, rivers would still flow, the sun would still rise and set. The flood, for all its scale, would be just one part of a larger ongoing story. If you were able to stay long enough to see the sea approach its modern level, you would witness a gradual calming. The dramatic daily advances of the shoreline would slow. The cascade at the narrow gate would soften into a steady exchange. The surface of the sea would settle into more predictable patterns of waves and currents. The region would begin to feel, in a sense, complete. Not finished, because the planet never truly stops changing, but settled into a state that would persist for a very long time. From that point on, the world you see would start to resemble the Mediterranean landscape we recognise today, at least in broad outlines. Coastlines that curve and fold, mountain ranges rising near the shore, rivers meeting the sea in wide deltas, winds shaping clouds and waves. The difference is that you would carry the memory of what it looked like before, of a vast dry basin beneath the sun, of a narrow gate holding back an ocean, of a waterfall taller than mountains. That memory would change how you see everything that came after. In a way, that's similar to how we experience the world now, through the lens of knowledge rather than direct memory. We look at a calm sea and, if we know the story, we can imagine the drama that once took place beneath and around it. We can picture the water rushing in, the land giving way, the sky filling with clouds. We can hold both images at once, the peaceful surface and the powerful past. That's one of the quiet gifts of science. It adds depth to what we see, turning familiar landscapes into windows onto deep time. If you step outside tonight and look at the sky, you might see clouds moving slowly across the stars or the glow of a distant city reflecting off the horizon. It might feel still, settled, ordinary, but beneath that stillness lies a world that has changed in ways that would have been impossible to imagine without the clues left behind. The idea of standing at the edge of the rising Mediterranean, watching a sea being born, brings that sense of possibility into focus. It reminds us that the Earth is not a static stage, but a living system, always in motion, always capable of reshaping itself in ways that are both gentle and dramatic. Long before anyone drilled into the seafloor, long before sonar traced hidden valleys beneath dark water, and long before the idea of deep time entered human thought, people were already telling stories about floods. Not just small, local floods that followed heavy rains or river overflows, but immense ones. Waters that covered whole worlds, seas that rose and erased what came before. Stories that appeared in cultures separated by oceans and thousands of years, yet carried surprisingly similar shapes. A time of calm, a warning, or a sign. Then water, spreading, covering, transforming everything in its path. If you step into that space between science and story, between rock layers and spoken memory, the Mediterranean becomes something more than a body of water. It becomes a setting for imagination, a place where human attempts to understand the planet's power and unpredictability found expression long before there were tools to measure or models to simulate. Around the shores of this sea, some of the world's oldest civilizations emerged. They built cities, grew crops, traded across the water, and passed down stories that explained how the world came to be and how it could change. In those stories, water often plays a central role. Ancient Mesopotamian texts speak of a great flood sent by the gods, a deluge that wiped away humanity, except for a chosen few who survived in a vessel. Later, similar narratives appear in other traditions, describing vast waters that reshape the world and mark a boundary between an old age and a new one. These stories are not records in the scientific sense. They don't tell us dates or water levels or tectonic movements. But they do tell us something about how deeply the idea of overwhelming water is woven into human thought. Living near rivers and seas, people have always been aware of how powerful water can be. A river that brings life to fields can also wash them away. A calm sea can become a storm-driven force that destroys ships and harbours. So when people tried to imagine the ultimate expression of natural power, they often turned to floods. The Mediterranean region, with its long history of changing coastlines, shifting rivers, and sometimes dramatic weather, would have been a fertile ground for such ideas. As sea levels rose and fell over thousands of years due to climate changes, shorelines would move. Settlements built near the water might find themselves closer to or farther from the sea over generations. A particularly intense storm or series of floods could leave a lasting impression, remembered and retold long after the physical traces faded. These lived experiences layered over time could feed into larger, more symbolic stories. What's fascinating is how these human narratives echo, in a very broad way, the scientific story of the Mediterranean's past. A world before the water, a moment of transformation, a new world after. Of course, the Zanclean Flood happened millions of years before any humans were around to witness it. There is no direct memory of that event in human culture. But the structure of the story, the idea that seas can vanish and return, that water can arrive in a way that changes everything, resonates with something very old in the human imagination. It's almost as if, when people look at a sea, they sense not just what it is, but what it could become. Standing on a shoreline, watching waves roll in and out, it's easy to feel the rhythm and stability of the ocean, but it's also possible to feel its potential, the sense that this calm surface is connected to something vast, deep, and powerful. In ancient times, without scientific explanations, that sense of potential often took the form of myth. Gods of the sea, spirits of rivers, stories of punishment or renewal delivered through water. These ideas appear again and again across different cultures. In the Mediterranean world, this took many forms. Greek mythology, for example, tells of Deucalion and Pyrrha, survivors of a great flood sent by Zeus to cleanse the world. In other traditions around the region, water is associated with both creation and destruction, with beginnings and endings. These stories are not attempts to describe a specific geological event. They are ways of expressing a relationship with the environment, ways of acknowledging that human life exists at the mercy of forces far larger than any individual or society. From a scientific perspective, the Mediterranean's dramatic past adds an interesting layer to this relationship. When geologists began to piece together the story of the basin's dry period and rapid refill, they weren't thinking about myths. They were looking at rock layers, chemical signatures, and the shapes of the sea floor. But the story they uncovered had a narrative quality to it. A missing sea, a sudden return, a transformation that reshaped a region. It's the kind of story that, if it had happened within human memory, would almost certainly have become the basis for legends. This doesn't mean that ancient flood myths are memories of the Zanclean Flood. The timescales simply don't match. But it does suggest that the Earth's capacity for dramatic change is something people have always sensed, even without knowing the details, and the Mediterranean, with its enclosed nature and long history of interaction between land and water, makes that sense especially vivid. Over the past few thousand years, the Mediterranean shoreline has changed noticeably in some places. River deltas have grown outward, pushing the coast into the sea. In other areas, erosion has pulled the land back. Cities that were once ports are now inland. Harbours that once sheltered ships are now silted up or exposed. These changes happen slowly, but over generations they become part of local memory. Stories get told about how the sea used to be closer, how a particular rock used to be underwater, how a valley once held a lake. These small-scale changes can, over time, blend into larger, more symbolic narratives. So when people hear or tell stories about a great flood, they may be drawing on a mix of real, observed changes and imaginative extensions of them. The scientific story of the Zanclean Flood adds a deep time dimension to this process. It shows that, on a scale far beyond any human memory, the Mediterranean itself has undergone a transformation that fits the broad outline of those myths, a before, a dramatic change, an after. There's a quiet connection there, not in the sense of direct transmission, but in the sense of shared themes. Both science and myth are, in their own ways, attempts to answer the same kinds of questions. Where did this world come from? How does it change? What forces shape it? Science answers by measuring, modelling, and testing. Myth answers by telling stories that give meaning and context. When you place them side by side, you can see how they sometimes trace similar shapes, even if the details and methods are very different. The Mediterranean's real geological history, with its vanished sea and dramatic return, feels almost like a natural myth written into the earth itself. It's a story that doesn't need embellishment. The basic facts are already striking. A basin isolated from the ocean, water evaporating, salt building up, a narrow gate opening, an ocean pouring in. These are elements that would not feel out of place in an ancient tale, even though they come from careful scientific reconstruction. There's something deeply human about that overlap. It suggests that when we tell stories about floods and lost worlds, we're tapping into a genuine aspect of how the planet behaves. Not necessarily recalling specific events, but recognizing patterns of change that are real and powerful. In the modern world, we often draw a sharp line between myth and science. One is seen as symbolic, the other as factual. But historically, They've both served as ways of engaging with the same environment. A farmer watching a river rise might tell a story about an angry god. A scientist watching a sea level graph rise might talk about climate systems and ice melt. Both are responding to the same phenomenon, just in different languages. The Mediterranean, as a place where land, sea and culture have intersected for thousands of years, is rich in both kinds of language. Its coastlines are dotted with ruins of ancient cities, temples and ports. Its waters have carried ships, traders and travellers. Its winds and storms have shaped the experiences of countless generations. And beneath all of that, hidden from view, lies a record of a transformation so large that it almost feels like it belongs to the realm of legend. When modern researchers talk about the Zanclean Flood, they often use precise terms: flow rates, elevation differences, sediment layers, isotope ratios. But if you strip away the technical language, the underlying story is simple. A sea disappeared, and then it came back. That simplicity is part of what makes it resonate beyond the scientific community. It's a story that can be understood on an intuitive level, even without the details. You don't need to know how to read a seismic profile to grasp the idea of a vast empty basin being filled by an ocean. And because of that, the scientific story can feel almost like a bridge between the modern, analytical way of seeing the world and the older, narrative way of making sense of it. It allows us to hold both perspectives at once. You can look at a salt layer beneath the seafloor and see a chemical record of evaporation. You can also look at it and imagine a dry, sunlit world where a sea once lay. You can trace an underwater channel on a sonar map and see the path of ancient rivers. You can also picture water rushing through that same space in a flood that reshaped a region. Both views enrich each other. This blending of perspectives becomes especially interesting when you think about how people have always been drawn to the idea of lost lands and drowned worlds. Legends of cities beneath the sea, of continents that sank, of realms claimed by water appear in many cultures. These stories often serve as warnings, reminders of impermanence, or symbols of renewal. The Mediterranean's real geological history doesn't include sunken human cities on a grand scale from the Zanclean period, but it does include a very real example of a landscape that was claimed by the sea. That fact alone can give those legends a different kind of weight. Not because the legends are literally true in a geological sense, but because they reflect an understanding that the boundary between land and water is not fixed forever. Even today, that boundary is changing. Rising global sea levels driven by climate change are altering coastlines around the world. Low-lying areas are becoming more vulnerable to flooding. Islands face the possibility of becoming uninhabitable. In this context, the story of the Zanclean Flood takes on a subtle, modern relevance. It reminds us that seas can rise, sometimes dramatically, and that landscapes we take for granted can change. The difference, of course, is in the timescale and the causes. The Zanclean Flood was driven by tectonic changes and gravitational flow. Modern sea level rise is driven by the warming of the climate and the melting of ice. But in both cases, water is the agent of change. This connection can add another layer to how we think about ancient flood myths. Those stories often carry a sense of warning or transformation. They mark a moment when the world is forced into a new state. In a modern context, we might see them as metaphors for the idea that human societies need to pay attention to the forces shaping their environment. The Mediterranean's geological past shows that those forces operate whether or not anyone is paying attention. There's a certain humility in that realization. We are part of a much longer story, one that began long before humans appeared and will continue long after. The myths we tell and the science we practice are both ways of trying to find our place within that story. When you stand on a Mediterranean beach today, watching the waves come in, it can be easy to feel a sense of timelessness. The sea seems ancient and enduring, as if it has always been there. But if you know its history, you also know that it hasn't. There was a time when this water was not here, a time when this place was dry land under the sun, a time when rivers flowed across a basin instead of into a sea. And then In a moment of geological drama, the water returned. That knowledge can change the way the present feels. It can add a layer of depth to something as simple as the sound of waves or the smell of salt in the air. Those everyday sensations become connected to a story that stretches back millions of years. In that sense, the Mediterranean is not just a sea, it's a kind of living reminder of the planet's capacity for transformation. The echoes of ancient flood myths and the very real story written into the seafloor meet in that reminder. One speaks in symbols and stories, the other speaks in layers of rock and patterns of erosion. Together they form a richer picture of a world that is both meaningful and measurable, both imagined and observed. You might notice how it changes the way you think about the stories we tell today. What kinds of myths are we creating now, in an age of satellites and climate models? What stories will future generations look back on and see as reflections of the world we lived in? The Zanclean Flood, though far removed from human memory, offers a kind of backdrop for those questions. It shows that the Earth's story is full of moments of dramatic change, moments that invite interpretation as much as explanation. Far from the roar of ancient water and the drama of rising seas, the story of how this flood was uncovered begins in places that feel almost the opposite of spectacular. Quiet laboratories, research ships moving steadily across calm water, long tables covered with rock samples, notebooks and instruments designed to notice details too small for the human eye to catch on its own. The discovery did not happen in a single moment of realization. There was no dramatic announcement, no sudden consensus. Instead, it unfolded slowly, through a series of questions that didn't quite fit the world, as scientists thought they understood it. One of the earliest clues came not from the surface of the Mediterranean, but from deep below it. As drilling technology improved in the middle of the 20th century, researchers gained the ability to collect long cores of sediment from beneath the seafloor. These cores are essentially vertical timelines. The youngest layers sit at the top, and as you go deeper, you move backward through time. Each layer represents a period when material settled out of the water and accumulated on the basin floor. When scientists began examining these cores from different parts of the Mediterranean, they noticed something unusual. Beneath the expected layers of marine sediment, filled with the remains of tiny sea creatures and fine particles carried in by rivers, they found something else. Thick, repeating layers of salt and other minerals that form when seawater evaporates. These were not thin, scattered patches. In some places, the salt deposits were hundreds of meters thick. This raised an immediate question. The Mediterranean is a sea. It's connected to the Atlantic. Under normal conditions, even in a hot climate, it shouldn't be able to evaporate enough to leave behind such enormous volumes of salt. The Atlantic should keep refilling it, maintaining a balance. So how did these layers get there? At first, the idea that the Mediterranean might have nearly dried up sounded extreme. The scale of it seemed hard to accept. But the evidence in the rock cores was difficult to explain any other way. The minerals found in these layers matched what you'd expect from evaporating seawater. Not fresh water, not some other chemical process. Salt, gypsum, and other evaporate minerals that form as water disappears and leaves its dissolved contents behind. And these layers weren't isolated. They appeared across large portions of the basin. This suggested that whatever had happened, it had affected the entire Mediterranean, not just a small local area. Around the same time, another line of evidence was coming into focus. Marine geophysicists were using sonar and seismic techniques to map the shape of the seafloor. By sending sound waves or seismic pulses downward and measuring how they bounce back, they could build images of what lay beneath the water and even beneath layers of sediment. What they found in parts of the Mediterranean was unexpected. Instead of a smooth, gently sloping basin floor, they saw deep, winding channels carved into the underlying rock. These channels looked remarkably like river valleys. They had branching patterns, steep sides, and shapes that suggested flowing water moving downhill across dry land. But these features were now buried beneath marine sediments and seawater. The presence of these ghost valleys raised another question. Rivers don't carve valleys underwater. They carve them in air when water flows across exposed land. So if these channels existed beneath the Mediterranean, it implied that, at some point, that land had been above water. This idea began to take shape. A basin that was once dry, rivers flowing across it, salt layers forming as water evaporated, then later a return to marine conditions. Piece by piece, a picture emerged that was very different from the traditional view of the Mediterranean as a long-standing, stable sea. The next challenge was figuring out when all of this had happened. Dating geological layers is a bit like solving a puzzle, with many different types of clues. In some cases, scientists can use radioactive elements that decay at known rates. In others, they rely on the remains of microscopic organisms that lived at specific times in Earth's history. In the Mediterranean cores, the layers above and below the salt deposits contain tiny fossils, such as foraminifera and other planktonic organisms. These creatures evolve relatively quickly, so their presence can be used to narrow down the age of the sediments. By comparing the species found in different layers to those found in well-dated sequences elsewhere in the world, researchers were able to estimate when the dry period and the return of the sea took place. The results pointed to the late Miocene and early Pliocene epochs, around 5 to 6 million years ago. This placed the event in a time when the continents were already close to their modern positions, when many familiar groups of plants and animals were already present, but long before any human ancestors would have been around to witness what happened. As more data came in, scientists began to realize that the Mediterranean's connection to the Atlantic must have been restricted or cut off during this period. The most likely place for that to happen was the narrow region around what is now the Strait of Gibraltar. Geological studies of that area showed signs of tectonic activity, uplift and subsidence. The African and Eurasian plates were moving relative to each other, creating a complex pattern of rising and sinking land. It was entirely plausible that, at some point, this movement could have raised a land barrier high enough to block the flow of Atlantic water into the Mediterranean. With the connection closed, evaporation would have begun to lower the water level in the basin. Over time, the sea could have shrunk dramatically, even nearly disappearing in some regions. This idea became known as the Messinian Salinity Crisis, a period when the Mediterranean experienced extreme evaporation and salt deposition. But that still left another question. How did the sea come back? This is where the concept of a massive flood began to take hold. If the basin had dropped far below the level of the Atlantic, then reopening the connection wouldn't just lead to a gentle return of water, it would create a situation where ocean water would rush downhill into the empty or partially empty basin, driven by gravity. Scientists began to look for evidence of such a dramatic inflow. The seafloor features near the Strait of Gibraltar provided some of the most compelling clues. Large eroded channels and scoured surfaces suggested the passage of enormous volumes of water at high speed. These features didn't match what modern currents or tides could produce. Their scale and shape pointed to something far more powerful. At the same time, sediment layers in the basin showed signs of rapid deposition. In some places, coarse materials appeared above the salt layers, as if they had been carried in quickly by strong flows before finer sediments settled on top. The combination of these observations led to a bold hypothesis. The Mediterranean basin had been largely isolated and partially dried out. Then, at some point, the barrier at Gibraltar failed. The Atlantic poured in, refilling the basin in a geologically short period of time. This idea, sometimes referred to as the Zanclean Flood, was not immediately accepted by everyone. In science, especially when dealing with events of this scale, skepticism is natural. Researchers proposed alternative explanations. Some suggested that the refill could have happened more slowly, through a series of smaller connections opening and closing. Others argued that the salt layers could have formed in deep, isolated basins rather than across the entire Mediterranean. To test these ideas, more data was needed. International research programs began drilling more cores from different parts of the basin. Seismic surveys expanded, mapping larger areas of the seafloor and the layers beneath it. Computer models were developed to simulate how water would flow into the basin under different scenarios. These models were particularly important. By inputting estimates of the basin's depth, the height of the barrier, and the size of the opening, scientists could calculate how fast water would flow and how long it would take to refill the Mediterranean. Many of these simulations showed that once a significant opening existed, the flow would be extremely rapid. The difference in height between the Atlantic and the basin would drive a powerful, sustained current, capable of delivering enormous volumes of water in a relatively short time. This supported the idea that the refill was not a slow, gentle process, but a dramatic one. As the evidence accumulated, the picture became clearer, though still open to refinement. The Mediterranean had gone through a period of isolation and extreme evaporation. Thick salt layers formed. Rivers carved deep channels into the exposed basin floor. Then, when the connection to the Atlantic reopened, water rushed in and the sea returned. This sequence of events tied together many different lines of evidence: the salt deposits, the ghost valleys, the seafloor erosion near Gibraltar, the chemical signatures in marine sediments. Each piece on its own could be explained in various ways. Together they formed a coherent story. What makes this process of discovery especially interesting is how it spans so many different fields of science. Geologists study the rocks and sediments. Geochemists analyse the chemical makeup of minerals and fossils. Geophysicists map the structure of the seafloor and the Earth's crust. Paleontologists examine the remains of ancient life to help date layers and reconstruct past environments. Oceanographers model how water moves and mixes. All of these perspectives contribute to a fuller understanding of what happened. It's a reminder that understanding the Earth often requires looking at it from many angles at once. The story also highlights the role of technology in expanding our sense of what's possible to know. A few centuries ago, the idea of peering beneath the seafloor would have seemed like pure fantasy. Even a few decades ago, mapping the deep ocean floor in detail was extremely difficult. Today, with advanced sonar, deep-sea drilling, and powerful computers, scientists can explore environments that are physically inaccessible in ways that are still indirect, but remarkably informative. This doesn't mean the story is finished. There are still debates about the exact timing, the precise sequence of events, and the full global impact of the Mediterranean's isolation and refill. New data continues to refine the picture. Some researchers are exploring how this event may have influenced global ocean circulation, potentially affecting climate patterns beyond the region. Others are investigating how marine ecosystems recovered after the return of the sea. Each new study adds a bit more detail, a bit more nuance. In that sense, the discovery of the greatest flood in this region's history is not a single achievement. It's an ongoing process. What's especially striking is how the evidence for something so dramatic is in many cases subtle. A thin layer of a particular mineral, a slight change in the shape of a seafloor ridge, a tiny fossil with a specific chemical signature. These small details, when combined, point to a story of immense scale. There's a certain poetry in that, even though the work itself is deeply technical. It shows how big stories can be hidden in small things. The way this story emerged also reflects how scientific understanding evolves. Early ideas about the Mediterranean's past were simpler. The sea was assumed to have been more or less stable over long periods. The discovery of the salt layers and other anomalies forced a re-evaluation of that assumption. As more data came in, models became more complex. The narrative shifted from stability to dramatic change. This kind of shift is not unusual in science. It happens whenever new evidence challenges existing frameworks. What matters is not that the first ideas were wrong, but that the process allows for revision, for improvement, for a closer approach to what actually happened. In this case, That process has revealed a history that is far more dynamic and dramatic than many people might expect from a familiar body of water. The Mediterranean, often associated with calm blue seas and sunny coastlines, turns out to have a past that includes near desiccation and a massive flood. That contrast adds a layer of depth to how we see the region. It also provides a powerful example of how the Earth operates on timescales and in ways that are easy to overlook in everyday life. When you look at a map or stand on a beach, it's natural to think of the world as largely fixed. Mountains here, seas there, continents in their places. The story of the Zanclean Flood reminds us that this apparent stability is, in a deep sense, temporary. Over millions of years, connections open and close, seas appear and disappear, landscapes are reshaped. Science gives us the tools to uncover those stories, even when they're written far below the surface. As you think about how this discovery came together, it's worth noticing how human curiosity plays a central role. No one had to drill into the Mediterranean seafloor. No one had to map those hidden channels, but people did, driven by a desire to understand how the world works. That curiosity, combined with patience and careful analysis, turned a series of puzzling observations into a coherent narrative. It's a quiet, methodical kind of adventure. One that takes place in data sets, rock samples and models rather than in dramatic landscapes. But in its own way, it's just as expansive. It connects a modern research vessel, floating on the surface of the Mediterranean, to a moment millions of years ago when an ocean poured into an empty basin. It links a scientist examining a tiny crystal under a microscope to a waterfall taller than mountains. It bridges the present and the deep past. There is a certain way the Earth reveals its power that doesn't rely on explosions, fire, or sudden, violent motion. Instead, it shows up in moments when a balance quietly tips. When something that has been held in place for a long time finally finds a new path. The result can feel sudden, even though it was prepared by countless small changes that came before. The story of the Mediterranean's Great Flood is one example of that kind of moment, but it also points to something much broader. It hints at a planet that is not just shaped by slow, steady forces, but one that can, under the right conditions, change its face in ways that feel almost instantaneous when viewed across deep time. To sit with that idea is to shift how you think about the world beneath your feet. We often imagine the Earth as a solid, stable thing. Continents feel permanent, oceans feel eternal, mountains seem like they have always been there and always will be. On the scale of a human life, that's mostly true. But when you stretch the timeline out far enough, stability becomes something else entirely. What looks like a fixed feature becomes a phase. The Mediterranean basin, for millions of years, existed in one state. Then for a relatively brief interval, it existed in another, and then it shifted again. The same pattern appears in many parts of the planet's history, if you look closely enough. Take, for example, the way continents themselves move. The ground you stand on is part of a massive plate of rock that floats, in a very slow and heavy way, on the softer, hotter layers beneath it. These plates drift at speeds that are almost imperceptible, a few centimetres per year, about the rate at which your fingernails grow. Over a single lifetime, that movement is nothing. Over 1 million years, it's kilometres. Those slow movements build mountains where plates collide. They open oceans where plates pull apart. They close seas where plates push together. The narrow gate that once held back the Atlantic was shaped by exactly this kind of motion. Africa pushing north, Europe resisting, the crust folding, rising, sinking. A long, quiet process that eventually set the stage for a dramatic release of water. The release itself, compared to the slow build-up, was quick. This contrast between preparation and outcome is something you see again and again in Earth's history. A volcano can sit quietly for centuries, pressure building beneath the surface, magma slowly rising, gases accumulating. Then, in a matter of hours or days, it can reshape an entire landscape. A glacier can creep forward and backward over thousands of years, carving valleys and shaping mountainsides. Then, during a warming period, it can retreat rapidly, releasing vast amounts of water into rivers and seas. A river can slowly undermine a cliff, grain by grain, until one day a large section collapses, changing the course of the water and the shape of the land. In each case, the dramatic moment is the visible part of a much longer story. The Zanclean Flood fits into this pattern. The dramatic part is the image of an ocean pouring into an empty basin. The quieter part is the millions of years of tectonic movement, climate shifts, and erosion that made that moment possible. Thinking about the planet this way can feel both unsettling and oddly reassuring. Unsettling, because it reminds you that the world is not as fixed as it seems. Reassuring, because it shows that change is not random. It follows patterns. It emerges from processes that, while complex, are consistent and understandable. One of the most striking things about these reshaping moments is how they can link different parts of the planet together. The Mediterranean's flood was not just a local event. It was tied to the movement of tectonic plates that extend far beyond the basin itself. It was influenced by global climate patterns that affected evaporation rates and sea levels. It had potential connections to ocean circulation that reaches across the entire Atlantic. In that sense, a change in one region can ripple outward, touching systems far away. This interconnectedness is a defining feature of the Earth. The atmosphere doesn't respect borders. Ocean currents don't stop at coastlines. Tectonic plates don't align neatly with continents. Everything is part of a larger moving whole. When you look at the planet from space, this becomes easier to see. A blue sphere wrapped in white clouds, with brown and green land masses drifting across its surface. From that distance, the idea of fixed places starts to feel less convincing. The Earth looks more like a system in motion than a collection of static parts. The Mediterranean, in this view, is one small piece of a much larger picture. Its story of disappearance and return is echoed in different forms elsewhere. There have been times in Earth's past when large parts of what are now continents were covered by shallow seas. Fossils of marine organisms can be found high in mountain ranges, far from any modern coastline. These rocks tell of ancient oceans that once reached places that are now dry land. There have also been times when ice covered vast areas that are now temperate. Glaciers stretched across much of North America and northern Europe during the last ice age, reshaping the land as they advanced and retreated. In each case, the planet moved between different states, not abruptly on a human timescale, but often rapidly on a geological one. What makes the Zanclean Flood especially vivid is the clarity of the transition. A basin that was largely dry, a connection that opened, a sea that returned. It's a story with a clear before and after. But many of Earth's reshaping moments are less tidy. They involve overlapping processes, gradual shifts, and complex feedbacks that make it harder to draw a single line between one state and another. Climate change, for example, is not a single event. It's a collection of interacting trends. Changes in temperature influence ice cover. Changes in ice cover influence sea level. Changes in sea level influence ocean circulation. Changes in circulation influence climate again. The system loops back on itself. The Mediterranean's flood had its own loops. The return of the sea influenced the atmosphere. The atmosphere influenced rainfall. Rainfall influenced rivers. Rivers influenced sediment in the sea. Sediment influenced the shape of the seafloor. The shape of the seafloor influenced currents. Currents influenced the distribution of heat and salt in the water. Each part of the system fed into the others. Thinking about this can change how you see the idea of a moment in the planet's history. What feels like a moment from one perspective is often a phase from another. The flood, which might have taken months or years, sits between millions of years of preparation and millions of years of aftermath. It's a hinge point. There's a certain beauty in that idea. The notion that the planet's long, slow story includes these turning points, these places where one set of conditions gives way to another. For a human observer, such moments would be almost impossible to fully grasp in real time. You might notice the shoreline moving, the water rising, the weather changing, but you wouldn't necessarily know that you were standing at a point that would, millions of years later, be seen as a defining transition. This is one of the quiet differences between living through change and looking back at it. From within, change often feels like a series of small adjustments. From a distance in time, it can look like a dramatic shift. The Earth's ability to reshape itself is not limited to water and rock. Life plays a role too. The appearance of plants on land, for example, changed the way erosion works. Roots hold soil in place. Leaves influence how rain hits the ground. Organic material alters the chemistry of the soil and the water that flows through it. The spread of life into the oceans and the evolution of organisms that build shells or reefs has changed the shape of coastlines and the chemistry of seawater. In this sense, the planet is not just a physical system, it's a biological one. The Mediterranean's return set the stage for new ecosystems to develop. Those ecosystems, over time, would influence the way sediment is produced and deposited, the way nutrients move through the system, and even the way water circulates. So the flood didn't just reshape the land and the sea, it reshaped the living world that grew around it, and that living world in turn continued to reshape the planet. This back and forth between the physical and the biological is another layer of the Earth story. It's not just that the planet provides a stage for life, life also becomes part of the machinery that changes the planet. When you think about the Earth this way, it becomes less like a backdrop and more like a participant. The phrase, a planet that can reshape itself in a moment, takes on a different meaning in that context. The moment is not just a physical event, it's a point where many threads come together. Tectonics, climate, water, life. All of them align in a way that produces a visible shift. In the case of the Zanclean Flood, the alignment was particularly clear. A land barrier failed. Gravity took over. Water moved. But behind that simple chain of cause and effect lay a complex web of influences. This complexity is part of what makes the Earth such a rich subject for study. No matter how much we learn, there are always more layers to uncover, more connections to trace, more questions about how one change might influence another. That sense of ongoing discovery is reflected in how scientists continue to refine their understanding of the Mediterranean's past. New drilling projects can reveal details that weren't visible before. Improved models can test different scenarios. Better mapping can uncover features of the seafloor that were previously hidden. Each new piece of information doesn't just add to the story, it can change how the story is told. This is another way the planet reshapes itself, not physically, but in our understanding of it. The Earth's history is not just written in stone, it's also written in the shifting ideas we have about what that stone means. From a broader perspective, the Mediterranean story can serve as a kind of reference point. It shows that seas can come and go, that connections between bodies of water can open and close, that landscapes can change dramatically when a threshold is crossed. This doesn't mean that the same thing will happen again in the same way. The specific conditions that led to the Zanclean Flood were unique to that time and place. But it does mean that the planet is capable of dramatic reconfiguration under the right circumstances. In the present day, we're living in a time when the Earth is undergoing another set of changes, driven largely by human activity. Temperatures are rising, ice is melting, sea levels are creeping upward, weather patterns are shifting. These changes are unfolding on a timescale that is much faster than many of the natural processes we've been talking about. The Zanclean Flood, rapid as it was in geological terms, still took place over months or years, not days or weeks. The climate changes we're seeing today are happening over decades, not millennia. This comparison can add a layer of perspective. It doesn't mean that modern changes are more or less significant than ancient ones. It means they're different in kind and in cause. But in both cases, the underlying lesson is similar. The planet is dynamic. It responds to forces. It can move into new states. Understanding that doesn't necessarily tell us what will happen next, but it does remind us that the world we experience now is one version of many that the Earth has known and will know. There's a certain quiet humility in that thought. It places human history within a much larger frame. Our cities, our roads, our borders all sit on a surface that has been oceans and deserts, ice and forests, many times over. The ground beneath a modern coastal town might once have been a dry valley. The water beyond the harbour might once have been far away. This doesn't make human efforts meaningless. It just situates them within a broader story. As you let this idea settle, you might notice how it changes the way you think about time. Minutes and hours feel very immediate. Days and years feel like a medium scale, but millions of years stretch out in a way that's hard to truly grasp. Events like the Zanclean Flood act as anchors in that vast span. They give shape to a timeline that might otherwise feel too abstract to hold on to. They remind us that the planet's history is not just a blur of slow motion. It includes moments of intensity, of rapid change, of clear transitions. Those moments, when looked at from far enough away, can feel like punctuation marks in a long sentence. The Mediterranean's flood is one of those marks. It separates a world where the basin was largely dry from a world where it became a sea again. It connects tectonic movement, climate, water, and life into a single, coherent narrative. And it offers a glimpse of the planet's ability to move from one state to another when conditions align. Somewhere in the world right now, a window is open just a little. Air moves through it in a slow, almost unnoticeable way. Curtains shift. A distant sound, maybe traffic, maybe wind in trees, maybe the low hum of a city settling into the night, drifts in and then fades again. This is the present moment, quiet, ordinary and steady in a way that feels reassuring. It can be surprisingly grounding to begin here, in something so familiar after travelling so far back through time. If you imagine for a moment that beyond that window lies a coastline, even if only in your mind, you might picture the surface of a sea under the same sky you're looking at now. Waves moving in gentle patterns, reflections of light stretching and breaking across the water. A horizon that feels calm and fixed, as if it has always been there and always will be. The Mediterranean today often carries that feeling, a sense of permanence, of long unbroken continuity. Civilizations have risen and fallen along its shores, ships have crossed it for thousands of years, stories, songs and memories have been carried by its winds and currents. And yet behind that calm surface lies a history that is anything but still. The quiet sea outside your imagined window is the result of a dramatic return. A basin that once lay open beneath the sun. A narrow gate that once held back an ocean. A moment when water poured in and changed the shape of a region. It's an interesting contrast, this pairing of the everyday and the extraordinary. On one hand, the present feels simple. The water moves, the sky shifts, the world goes on. On the other, the past reveals how much effort, motion, and change went into creating this simplicity. If you were to walk along a modern Mediterranean shoreline, you might notice small details that seem almost trivial. Pebbles rolling back and forth with the waves, seaweed tangled around a piece of driftwood, the faint line of foam left behind as a wave retreats. These details are the surface expression of a system that has been in motion for millions of years. The water that touches your feet has likely travelled vast distances. It may have entered the Mediterranean through the Strait of Gibraltar, carrying with it traces of the Atlantic. It may have circulated within the basin, warmed by the sun, cooled by the night, mixed by winds and currents. Over time, it will leave again, flowing back out into the open ocean at depth, carrying the Mediterranean's saltier signature with it. This steady exchange is a quiet echo of the flood that once defined the region. Not a roar, not a cascade, but a constant, balanced movement. If you stand still long enough near the sea, you can begin to sense that balance. The tide rises and falls, the waves repeat their patterns, the breeze shifts direction, As the land warms and cools, there's a rhythm to it. Not a dramatic one, but a persistent one. It can be calming to think about how long that rhythm has been in place, and how much change it has outlasted. The modern Mediterranean has seen ice ages come and go. It has seen climates warm and cool. It has seen coastlines advance and retreat. Through all of that, the basic presence of the sea has remained. But if you know its deeper story, that presence takes on a different quality. It feels less like a permanent fixture and more like a long, ongoing phase in a much larger cycle. This perspective can gently shift the way you relate to the world around you. A mountain range that looks solid and unchanging becomes something that rose, slowly, over time, and will one day wear down again. A coastline that feels fixed becomes something that can move, given it enough time and the right conditions. The sea itself, often a symbol of constancy, becomes a reminder of change. There's something quietly comforting about that, even if it sounds counterintuitive. Change, in this sense, is not a sign of instability. It's a sign of continuity. The planet keeps moving, adjusting, finding new balances. The flood that refilled the Mediterranean was one such adjustment. The calm sea you imagine now is another. If you let your attention drift back to your own surroundings, you might notice how similar patterns play out on a much smaller scale. The air in the room warms and cools, sounds come and go, light shifts across walls and floors. Even in moments that feel still, there is motion. This kind of awareness can make the present feel richer, more layered. The world you're in now is not just the result of what happened yesterday or last year. It's the result of processes that stretch back millions, even billions, of years. The ground beneath your feet is part of a crust that has been folded, fractured, and reassembled countless times. The water you drink has cycled through clouds, rivers, seas, and ice. The air you breathe has been shaped by living things, by volcanoes, by oceans, by the slow turning of the planet under the sun. All of that history is present, in a quiet way, in this moment. The Mediterranean story is a particularly vivid example of this layering of past and present. To someone standing on a beach today, it's just a sea, a place to swim, to fish, to watch the sunset. To someone who knows its deeper history, it's also a record of a dramatic transformation, a place where an entire basin went from dry to full, from absence to presence. Both views are true at the same time. You don't have to choose between them. In fact, holding them together can make the experience of the present feel more expansive. When you hear the sound of waves, you can hear them as waves. Simple, repetitive, soothing. You can also hear them as the continuation of a much older movement, one that began when water first found its way back into an empty basin and never fully stopped. The same goes for the wind. A breeze moving across a modern shoreline is part of the same system that once carried mist from a massive cascade, that once shaped clouds over a newborn sea, that once helped spread moisture across newly formed coastlines. The scale is different, but the underlying processes are connected. There's a gentle sense of continuity in that idea. Nothing is isolated. Everything flows into everything else. The present moment, then, becomes a kind of meeting point, a place where deep time and immediate experience overlap. You can sit in a room, listening to distant sounds, feeling the air on your skin, and know that, in a very real way, you're part of a story that includes vanished seas and returning oceans. This doesn't mean you have to carry the weight of that story all the time. It's not a burden. It's more like a background presence, something you can notice when you want to, and let fade when you don't. In moments of rest, it can be enough just to feel the simplicity of being here. Breathing in, breathing out, the world moving quietly around you. If you imagine the Mediterranean at night, far from city lights, the scene can be especially peaceful. The surface of the water might be dark, reflecting only faint starlight or the glow of the moon. The horizon would blur into the sky. The sound of waves would soften into a steady low rhythm. From that perspective, it's easy to forget the dramatic past and simply experience the present, and yet knowing the past can add a layer of depth to that experience. The calm you see now is not the absence of movement. It's the result of a system that has found a balance, at least for this phase of the planet's history. The Mediterranean today is connected to the Atlantic in a stable way. Water flows in and out. Salinity levels are maintained. Currents circulate. Ecosystems thrive. That stability is what allows the sea to be what it is now, a place of relative calm, of predictable patterns, of familiar rhythms. But that stability exists within a larger context of change. The continents around the Mediterranean are still moving, even if the motion is too slow to notice. The climate is still shifting. The global ocean is still responding to changes in temperature and ice. Over very long timescales, the conditions that created the Zanclean Flood could, in theory, arise again in some form, somewhere else, or even here. Not in the same way, not with the same details, but as another expression of the planet's ability to move between different states. This is not something to worry about in a practical sense. It's far beyond the scope of any human lifetime or civilization. But it's something that can change how you think about what now means. The present becomes a snapshot in a very long sequence, a moment of relative calm between past changes and future ones. There's a kind of peace in that perspective. It suggests that you don't have to hold on to things as if they must last forever. You can appreciate them as they are, knowing they are part of a larger flow. The quiet sea outside your imagined window is one expression of that flow. So is the quiet room you're in now. So is the steady rhythm of your own breathing. All of them are small, local patterns within a much larger system. As this journey through the Mediterranean's deep past comes to rest in the present, you might notice how different it feels to think about time. At the beginning, the focus was on millions of years, on tectonic plates and vanished seas. Now the focus is on moments, on the air in a room, on the sound of water, real or imagined. Both scales are part of the same reality. You can move between them as easily as shifting your attention from the horizon to something close at hand. This ability to zoom in and out to hold both the vast and the immediate is one of the quiet strengths of human curiosity. It allows you to feel connected to something much larger without losing touch with where you are right now. If you let your thoughts settle here, you might find that the story of the flood fades into the background, not because it's unimportant, but because it's become part of a larger, calmer picture. The Mediterranean is here. The world is here. You are here. The sea that once rushed in now moves gently. The land that once lay dry now supports cities, forests, and fields. The sky that once carried storms and clouds over a newborn basin now carries them over a familiar, settled landscape. All of it continues, moment by moment. There's no clear ending to this kind of story, because the planet doesn't reach a final chapter. It keeps going, shifting, adjusting, finding new balances. In that sense, the present is not a conclusion. It's a pause, a place to rest your attention for a while. So if you're listening to this in a quiet space, you can let that pause be gentle. You can let the idea of a calm sea somewhere beyond a window or a wall become a simple image to hold. Not a symbol of dramatic change, not a reminder of deep history, but just a surface of water under a wide sky. Waves moving, wind passing, time continuing. And from that calm surface, the story doesn't really end. It simply drifts onward, carried by the same slow, steady motion that has always shaped the world.